Java Database Connectivity Architecture. Here you can see the architectural diagram of Java Database Connectivity. Java Database Connectivity JDBC is an application programming interface API for the programming language Java, which defines how a client may access a database. It is a Java-based data access technology used for Java database connectivity. It is part of the Java Standard Edition platform from Oracle Corporation. It provides methods to query and update data in a database and is oriented towards relational databases. A JDBC to ODBC bridge enables connections to any ODBC accessible data source in the Java Virtual Machine (JVM) host environment. Here you can see JDBC architecture. JDBC is similar in structure to ODBC. A JDBC application is composed of multiple layers as shown in this figure. The topmost layer in this model is a Java application. Java applications are portable. You can run a Java application without modification on any system that has a Java runtime environment installed. Java application that uses JDBC can talk to many databases with few, if any, modifications. Like ODBC, JDBC provides a consistent way to connect to a database, execute a command and retrieve the results. Also, like ODBC, JDBC does not enforce a common command language. You can use Oracle specific syntax when connected to an Oracle server, and Postgre SQL specific syntax when connected to a PostgreSQL server. If you stick to a common subset, you can achieve remarkable portability for your applications. The JDBC Driver Manager. The JDBC Driver Manager class is responsible for locating a JDBC driver needed by the application. When a client requests a database connection, the request is expressed in the form of a URL, Uniform Resource Locator. A typical URL might look like JDBC : PostgreSQL : movies. The JDBC URL is similar to the URLs that you use with the web browser. HTTP : www.postgresql.org, for example. The JDBC driver, as each driver is loaded into a Java virtual machine, it registers itself with the JDBC Driver Manager. When an application requests a connection, the Driver Manager ask each driver whether it can connect to a database specified in the given URL. As soon as it finds an appropriate driver, the search stops and the driver attempts to make a connection to the database. If the connection attempt fails, the driver will throw a SQL exception to the application. If the connection completes successfully, driver creates a connection object and returns it to the application. The JDBC 2.0 architecture introduced another method for establishing database connections: the data source. A data source is named connection properties that can be used to load the driver and create a connection. The PostgreSQL JDBC driver does not support the data source class. The JDBC compliant database, the bottom layer of the database model is the database. PostgreSQL driver class and other JDBC classes translates the application commands into PostgreSQL network request and translates the request back into the JDBC object form. Here you can see the Java application is connected to JDBC Driver Manager. JDBC Driver Manager interacts with JDBC drivers. Here PostgreSQL, here Oracle, and here Sybase. JDBC drivers interacts with databases. Here JDBC driver PostgreSQL interacts with PostgreSQL database. JDBC driver Oracle interacts with Oracle database. JDBC driver Sybase interacts with Sybase database. Here you can see a two-tier architecture for data access. The JDBC API supports both two-tier and three-tier processing models for database access. Here in the two-tier model, a Java applet or application talks directly to the data source. This requires JDBC driver that can communicate with the particular data source being accessed. A user commands are delivered to the database or other data source, and the results of those statements are sent back to the user. The data source may be located on another machine to which the user is connected via a network. This is refers to as a client-server configuration, with the user machine as the client and the machine housing the data source as the server. The network can be an intranet, which, for example, connects employees within a corporation, or it can be the internet. Here you can see the client machine, which has the Java application and JDBC, and JDBC is connected to DBMS through DBMS proprietary protocol, and here database server, and you can see the DBMS here. In the three-tier model, commands are sent to the to a middle tier of services, which then sends the command to the data source. The data source processes the commands and then send the results back to the middle tier, which then sends them to the user. MIS directors find the three-tier model very attractive because the middle tier makes it possible to maintain control over access and the kinds of updates that can be made to corporate data. Another advantage is that it simplifies the deployment of applications. Finally, in many cases, the three-tier architecture can provide performance advantages. Until recently, the middle tier has often been written in languages such as C or C or C++, which offer fast performance. However, with the introduction of optimizing compilers that translate Java bytecode into efficient machine-specific code and technologies such as enterprise Java Beans, the Java platform is fast becoming the standard platform for middle tier development. This is a big plus, making it possible to take advantage of Java's robustness, multi-threading, and security features. With enterprises increasingly using the Java programming language for writing server code, the JDBC API is being used more and more in the middle tier of a three-tier architecture. Some of the features that makes JDBC a server technology are its support for connection pooling, distributed transactions, and disconnected raw sets. The JDBC API is also what allows access to a data source from a Java middle tier. Here you can see the client machine GUI. It has a Java applet or HTML browser. Server machine, the business logic has application server Java, JDBC, HTTP, RMI, COBA, or other calls are passed from client machine to server machine and server machine to client machine. Here you can see the database server DBMS, and DBMS proprietary protocol is passed from server machine to database server and database server to server machine. And client machine interacts with server machine server machine interacts with database server. The protocol for communicating with the database normally is not compatible across different databases. Therefore, there is a need for a product known as a database driver to convert the JDBC calls into the native call for the particular database. Needless to say, each database requires a different driver. Applications that use JDBC communicate to the database by using drivers. JDBC consists of two major sets of APIs, one for the application developers and another low-level JDBC Driver API for driver developers. JDBC drivers fit into 4 different categories. Here you can see JDBC Architecture Type 1 drivers. The original JDBC implementation simply leverage the features offered by ODBC drivers. Because ODBC had become quite popular, several ODBC drivers were already available in the market. Type 1 drivers use the existing ODBC drivers and provide a bridge which convert the JDBC API calls to ODBC API calls. These are commonly referred as the JDBC ODBC bridge. Previously using these drivers has performance implication because there is another layer ODBC to convert to. Another disadvantage is that ODBC native code must be loaded on the client machine. Because this type of driver uses native code, you cannot use them in an application such as an applet that works in the Java sandbox. Type 1 drivers are rarely used today. This figure outlines a simple JDBC architecture using this type of driver. This type 1 JDBC drivers translate JDBC calls into ODBC calls. Type 1 JDBC drivers are usually called JDBC ODBC bridge drivers. Here you can see applications interacts with JDBC API. JDBC API interacts with driver manager and data source. Driver manager and data source interacts with JDBC ODBC bridge type 1 driver. JDBC ODBC bridge interacts with ODBC. ODBC interacts with DB client lib. DB client lib interacts with database. Here you can see JDBC architecture type 2 drivers. A type 2 driver converts JDBC calls directly into the client's API provided by the database without need for an intermediate ODBC layer. For this reason, these drivers offer better performance than type 1 drivers. Such drivers are known as native API partly Java drivers. Type 2 drivers communicate with the database by using the native client library provided by the database. This library is required to be loaded on the client machine. Because of this, applets cannot use these type of drivers. This architecture can be seen in this figure. Type 2 JDBC drivers translate JDBC calls into native DBMS APIs. Type 2 drivers consist of Java components and a native code component, which requires that binary code be loaded into each client machine. Here you can see applications interact with JDBC API. JDBC API interacts with driver manager and data source. Driver manager and data source interact with native API partly Java type 2 driver. Native API partly Java type 2 driver interacts with DB client library. DB client library interacts with database. Here you can see JDBC architecture type 3 drivers. These drivers follow the three tiered approach. To client server applications. The driver converts JDBC calls into the middleware protocol and is sent to the server middle tier. The calls are then converted to DBMS protocol inside the middleware and sent to the database. The middleware usually supports several databases, thus providing access to different databases to clients. Such drivers are usually referred to as the net protocol all Java drivers. This type of driver is usually useful for providing database access to applets directly. These drivers act as a proxy for database access by applets and other applications. This figure represents a typical architecture using type 3 driver. Type 3 JDBC drivers are pure Java drivers that use database middleware. Type 3 drivers communicate with database through middleware servers that must be running in the network. .NET protocol, the NET protocol allows the client JDBC drivers to be very small and load quickly. Fetching data rows may take longer because the data comes through middleware server. Here you can see applications interacts with JDBC API. JDBC API interacts with driver manager and data source. Driver manager and data source interact with NET protocol all Java type 3 driver. NET protocol all Java type 3 driver interacts with middleware interacts with database. Here you can see JDBC architecture type 4 drivers. Type 4 drivers, native protocol, all Java drivers talk pure Java. They are aware of the underlying protocol used by the database, and they communicate directly with the database without use of a middle layer. JDBC calls are converted into vendor specific DBMS protocols. These are the difference between type 4 and type 2 drivers is that these drivers are implemented fully using Java without the need for native libraries. Being pure Java provides very good performance compared to their mixed counterparts. Because no native code is used, these drivers may be used by applets. Your application obviously needs different drivers to communicate with different databases while using this type of drivers. This figure represents a simple architecture using a type 4 driver. Type 4 JDBC drivers are pure Java drivers that can access a database directly. Type 4 drivers are sometimes called thin drivers. Type 4 the JDBC drivers have relatively fast performance. Here you can see applications interacts with JDBC API. JDBC API interacts with driver manager and data source. Driver manager and data source interact with native protocol or Java type 4 driver. Native protocol or Java type 4 driver interacts with database. Here you can see a two-tier model. A two-tier model divides functionality into a client layer and a server layer, as shown in this figure. The client layer includes the application or applications and or one or more JDBC drivers, with the application handling these areas of responsibility: presentation logic, business logic, transaction management for multiple statement transactions or distributed transactions, resource management. In this model, the application interacts directly with the JDBC drivers, including establishing and managing the physical transactions and handling with the details of specific underlying data source implementations. The application may use its knowledge of a specific implementation to take advantage of non-standard features or do performance tuning. Some drawbacks of this model include mingling presentation and business logic with infrastructure and system level functions. This presents an obstacle to producing maintainable code with a well-defined architecture. Another drawback is making applications less portable because they are tuned to a particular database implementation. Applications that require connections to multiple databases must be aware of the differences between the different vendors' implementations. Limiting scalability. Typically, an application with will hold into one or more physical database connections until it terminates. Handling the number of concurrent applications that can be supported. In this model, the issues of performance, scalability, and availability are handled by the JDBC driver and the corresponding underlying data source. If an application deals with multiple drivers, it may also need to be aware of different ways in which each driver data source pair resolves these issues. Here, application interacts with JDBC driver and JDBC driver interacts with data source. Here you can see a three-tier model. The three-tier model introduces a middle-tier server to house business logic and infrastructure, as shown in this figure here. This architecture is designed to provide improved performance, scalability, and availability of enterprise applications. Functionality is divided among the tiers as follows. 1. Client tier. A thin layer implementing presentation logic for human interaction. Java programs, web browsers, and PDAs are typically client tier implementations. The client interacts with the middle tier application and does not need to include any knowledge of infrastructure or underlying data source functions. 2. Middle tier server. A middle tier that includes applications to interact with the client and implement business logic, If the application includes interaction with the data source, it will deal with higher level abstractions such as data source objects and logical connections rather than lower level APIs. An application server to provide supporting infrastructure for a wide range of applications. This can include management and pooling of physical connections, transaction management, and transaction management and masking of differences between different JDBC drivers. This last point make it easier to write portable applications. The application server role can be implemented by a Java EE server. Application servers implements higher level abstractions used by applications and interact directly with JDBC drivers. And JDBC drivers to provide connectivity to underlying data sources. Each driver implements the standard JDBC API on top of whatever features are supported by its underlying data source. The driver layer may mask differences between standard SQL 2003 syntax and the native dialect supported by the data source. If the data source is not relational, the DBMS, the driver implements the relational layer used by the application server. The underlying data source, the tier where the data resides, the underlying data source, the tier where the data resides, it can include relational DBMSs, legacy file systems, object-oriented DBMSs, data warehouses, spreadsheets, and other means of packaging and presenting data. The only requirement is a corresponding driver that supports the JDBC API. Here you can see a web client browser is connected to middle tier server. Middle tier server includes application server, transaction manager, JDBC drivers. Here application server interacts with applications and JDBC drivers and transaction manager. JDBC drivers are connected to data sources here. Here you can see relationships between major classes and interfaces in the java.sql package. The core JDBC API is contained in the package java.sql. The enums, classes, and interfaces in java.sql are listed above here. Enums and classes are here the interface connection in package java.sql in module java.sql. A connection session with the specific database. The SQL statements are executed and results are returned within the context of connection. Here the interface statement, the object used for executing a static SQL statement and returning the result it produces. Here interface prepared statement, an object that represents a compiled SQL statement. Here the interface callable statement, the interface used to execute SQL stored procedures. The JDBC API provides a stored procedure SQL escape syntax that allows stored procedures to be called in a standard way for all RDBMSs. This escape syntax has one form that includes a result parameter and one that does not. If used, the result parameter must be registered as an out parameter. The other parameter can be used for input, output, or both. The parameters are referred to sequentially by number, with the first parameter being 1. Interface result set. A table of data representing a database result set, which is usually generated by executing a statement that queries the database. Here you can see connection. Connection is connected to statement via create statement. And a connection is connected to prepared statement via prepare statement, and connection is connected to callable statement via prepare call. Here the statement is connected to prepared statement via subclasses, and prepared statement is connected to subclass callable statement via subclasses. And here statement is connected to result set via execute query. Here the prepared statement is connected to result set via execute query, and result set is connected to data types via get xxx, and here callable statement is connected to result set via execute query, and get more results, get result, or get result set. Here the result set is connected to data types via get xxx, and data types are connected to prepared statement via input to prepared statement, and here callable statement interacts with here data types interacts with callable statement via input or output of callable statement. Here you can see the relationship between javax.sql.data source and java.sql.connection. Here the interface data source in package javax.sql and in module java.sql. A factory for connections to the physical data source that this data source object represent. An alternative to the driver manager facility, a data source object is preferred means of getting a connection. An object that implements the data source interface will typically be registered with the naming service based on the Java naming and directory JNDI API. Interface connection in package java.sql in module java.sql. A connection session with a specific database. SQL statements are executed and results are returned within the context of a connection. Here data source is in package javax.sql, and here connection is in the package java.sql, and data source is connected to connection via get connection. Here you can see the relationships involved in connection pooling. Here the interface connection pool data source in package javax.sql in module javax.sql. A factory for pooled connection objects. An object that implements this interface will typically be registered with the naming service that is based on the Java naming and directory interface JDBC. Interface pooled connection. An object that provides hooks for connections pool management. A pooled connection object represents a physical connection to a data source. The connection can be recycled rather than being closed when an application is finished with it, thus reducing the number of connections that need to be made. The class connection event. An event object that provides information about the source of a connection related to that related event. Connection event objects are generated when an application closes a pooled connection and when an error occurred. Connection event object contains two kinds of information. The pooled connection closed by the application. In the case of an error event, there's a SQL exception about to be thrown to the application. Here the interface connection in package in a connection session with a specific database. SQL statements are executed and results are returned within the context of a connection. Here the interface connection event listener, an object that registers to be notified of event generated by the pool connection object. Here connection is in the package java.sql. Here the connection pool data source, pool connection event and connection event listener are in the package javax.sql. Here the connection pool data source is connected to pool connection via get connection. Here pool connection is connected to connection via get connection. Here pool connection is connected to connection event via close or error event. And here you can see connection event listener. Here you can see relationships involved in distributed transaction support. Here the interface pooled connection, an object that produces provides hooks for connection pool management. A pooled connection object represents a physical connection to data source. The connection can be recycled rather than being closed when an application is finished with it, thus reducing the number of connections that need to be made. The interface XA data source, a factory for XA connection objects that is used internally. An object that implements the XA database interface is typically registered with the naming service that uses the Java naming and directory interface JDBC. Interface XA connection, an object that provides support for distributed transactions. An XA connection object may be enlisted in a distributed transaction by means of a XA resource object. A transaction manager, usually part of a middle tier server, manages an XA connection object through a XA resource object. Interface XA resource. The XA resource interface is a Java mapping of the industry standard XA interface based on the XOpen CAE specification, distributed transaction processing, the XA specification. Interface connection, a connection session with the specific database. SQL statements are executed and results are returned within the context of a connection. Class connection event, an event object that provides information about the source of a connection related event. Connection event objects are generated when an application closes a pool connection and when an event occurs. The connection event objects contains two kinds of information. The pool connection closed by the application. In case of an error event, the SQL exception about to be thrown in the application. Interface connection event listener. The connection event interface is implemented by a connection pooling component. A connection pooling component will usually be provided by a JDBC Driver vendor or another system software vendor. JDBC Driver notifies connection event listener object when application is finished using a pool connection with which the listener has registered. The notification occurs after application calls the method close on its representation of a pool connection object. A connection event listener is also notified when a connection error occurs due to the fact that pool connection is unfit for future use. The server has crashed, for example. The listener is notified by the JDBC driver just before the driver throws an SQL exception to the application using the pooled connection object. Here the pooled connection subclass is a XA connection and XA data source is connected to XA connection via get XA connection. Here the you can see the XA connection and pooled connection, XA source, XA connection, connection event and connection event listener are in javax.sql package. Here the XA connection is connected to XA resource via get XA resource. XA resource is in javax.transaction.xa package. Here the connection is connected to connection event via close or error event. You can see here connection event listener. Here XA connection is connected to connection via get connection. Connection is in the package java.sql. Here you can see row set relationships. Here you can see result set, interface result set, a table of data representing a database result set, which is usually generated by executing a statement that queries the database. Here the interface row set, the interface that adds support to the JDBC API for the Java Beans component model. A row set which can be used as a Java Beans component, which in a visual bean development environment can be treated and configured at design time and executed at runtime. Class row set event, an event object generated when an event occurs to a row set object. A row set event object is generated. A row set event object is generated when a single row in a row set is changed, the whole row set is changed, or the row set cursor moves. Here interface row set metadata, an object that contains information about the columns in a row set object. This interface is an extension of the result set metadata. Interface with methods for setting the values in row set metadata object. When a row set reader object reads data into a row set object, it creates a row set metadata object and initializes it using the methods in the row set metadata interface. When a reader passes the rowset metadata object, then the reader passes the metadata object to the rowset. Interface result set metadata, an object that can be used to get information about the types and properties of the columns in a result set object. Interface rowset internal, the interface that a rowset object implements in order to present itself to a rowset reader or rowset writer object. The rowset internal interface contains methods that let the reader or writer access and modify the internal state of the rowset. Interface rowset reader, the facility that a disconnected rowset object calls on to populate itself with raw data. A reader and object implementing the rowset reader interface may be registered with the rowset object that supports the reader writer paradigm. When rowset objects execute method is called, it in turn calls the reader's read data method. Interface rowset writer, an object that implements the rowset writer interface called a writer. A writer may be registered with the rowset object that supports the reader writer paradigm. Here in result sets and result set metadata in SQL java.sql package. Here the rowset event listener, rowset metadata, rowset internal, rowset reader, rowset writer are in javax.sql package. Here the result set subclasses rowset, and rowset is connected to rowset event, and here you can see rowset event listener. Here the rowset metadata is connected to rowset via retrieve metadata. Here the here rowset metadata subclasses rowset result set metadata subclasses rowset metadata. Here the rowset internal is connected to rowset reader. Here the via reads data. Here rowset writer is connected to rowset internal via writes data. Here you can see the connection pooling. In the basic data source implementation, there is a one-to-one correspondence between the client's connection object and the physical database connection. When the connection object is closed, the physical connection is dropped. Thus, the overhead of opening, initializing and closing the physical connection is incurred for each client session. Connection pool solves this problem by maintaining a cache of physical database connections that can be reused across the client sessions. Connection pooling is greatly improves the performance and scalability, particularly in a three-tier environment where multiple clients can share a smaller number of physical database connections. Connection pool data source that the application server uses to build and manage the connection pool. The algorithm used to manage the connection pool is implementation specific and varies with the application servers. The application server provides its clients with an implementation of a data source interface that makes connection pooling transparent to the client. As a result, the client gets better performance and scalability while using the same JNDI and data source APIs as before. we can consider connection pool data source interface, the pool connection interface, and the connection event class. These pieces which operate beneath the data source and connection interfaces used by the client are incorporated into a step-by-step description of a typical connection pooling implementation. Here JDBC application interacts with the application server. JDBC application is connected to application server via data source API, and application server is connected to JDBC application via logical connection object. Cache of pool connection objects are inside the application server. Application server interacts with JDBC Driver. Application server is connected to JDBC Driver via connection pool data source API, and JDBC Driver is connected to application server via physical pooled connection object. Here you can see a logical view of a prepared statement reused by pool connections. The JDBC specification provides support for statement pooling. This feature, which allows an application to reuse a prepared statement object in much the same way it can reuse a connection, is made available through a pool connection. This figure provides a logical view of how a pool prepared statement objects can be associated with the pool connection object. As with the pool connection object itself, the prepared statement objects can be reused by multiple logical connections in a transparent manner. In this figure, the connection pool and statement pool are implemented by application server. However, this functionality could also be implemented by the driver or underlying data source. This discussion of statement pooling is meant to allow for any of this implementation. If we consider interface pool connection, an object that provides hooks for connection pool management, a pool connection object represents a physical connection to a data source. The connection can be recycled rather than being closed when an application is finished with it, thus reducing the number of connections that need to be made. If we consider class prepared statement in package java.sql in module java.sql, an object that represents a compiled SQL statement. Here JDBC applications are connected to pool connection here, and just another JDBC application is connected to another pool connection. Here the pool of prepared statement objects and pool connections are inside connection pool, and connection pool is inside application server. Here the pool of prepared statement objects interacts with pool connection, and pool connection is connected to data source here, and here also the same. Here you can see infrastructure for distributed transactions. Distributed transactions require an infrastructure that provides these roles. transaction manager controls transaction boundaries and manages the two-phase commit protocol. This typically will be an implementation of JTA. JDBC drivers that implements the XA data source, XA and XA connection, and XA resources interfaces. These are interfaces, and an application visible implementation of data source to sit on top of each XA data source object and interact with the transaction manager. The data source implementation is typically provided by an application server. Resource managers to manage the underlying data. In the context of JDBC API, a resource manager is a DBMS server. The term resource manager is borrowed from JTA to emphasize the point that describe transaction using JDBC API follow the architecture specified in that document. This infrastructure is most often implemented in a three-tier architecture that includes the following: client tier, middle tier that include applications and EJB server working with external transaction manager and a set of JDBC drivers, and three multiple resource managers. Distributed transactions can be implemented in two tiers. In a two-tier architecture, the application itself acts as a transaction manager and interacts directly with the JDBC drivers. JDBC drivers XA data source implementation. This diagram illustrates the distributed transaction infrastructure. XA data source and XA connection interfaces, which are defined in the package javax.sql, are implemented by JDBC drivers that support distributed transactions. An XA connection object is a pooled connection that can participate in a distributed transaction. More precisely, XA connection extend pooled connection interface by adding a method getXA resource. This method produces an XA resource object that can be used by a transaction manager to coordinate the work done in the connection with the other participant in the distributed transaction. XA resource. The XA resource interface is defined with the JTA specification and is the mapping in the Java programming language of the XOpen group XA interface. An XA resource object is produced by calling XA connection dot get XA resource method and is used to associate XA connection object with distributed transaction. A given XA connection object may be associated with at most one of the transaction at a time. The JDBC driver maintains a one-to-one correspondence between XA resource object and its associated XA connection object that is multiple calls to the getXA resource method must all return the same object. Transaction management. The participation in a distributed transaction is defined and as work done between invocation of a method, method's XA resource start dot XA resource dot start and XA resource dot end. Outside these boundaries, the transaction mode is local and connection behaves exactly like a local connection. Closing the connection. A typical distributed transaction environment, middle tier server needs to be notified when an application has finished using a connection. As in the pool connection object, the middle tier server will add itself as a connection event listener so that it will be notified when the application calls the method connection.close. At this point, the server will notify the transaction manager so that it can end the transaction branch for the corresponding XA resource object. If the server's data source implementation includes connection pooling, the connection pooling module will be notified that it can return the physical XA connection object into the pool. Note, a distribution transaction may still be active after participating connection object is closed. This is not true for local transactions. Limitations of XA resource interface. The Java x.transaction.xa resource interface is limited to defining only the set of method needed to join and participate in global transactions as defined by the OpenXA standard. This allows any resource manager that implements the interface to participate with any other resource manager or transaction manager that has the same level of support. Here you can see JDBC application interacts with application server. JDBC application is connected to application server via data source API. Here the application pool for A and application pool for B are in application server. Application server interacts with JDBC drivers. Here the JDBC drivers and JDBC drivers interacts with resource managers. Here the JDBC application is connected to application server via data source API. Here the application server is connected to JDBC driver A via XA data source API. And JDBC driver A interacts with resource manager, and JDBC driver A is connected to physical XA, connected to application server via physical XA connection A1. Here the application server is connected to transaction manager via XA resource A1. And here the application server is connected to JDBC application via logical connection A1. And here the application server is connected to XA resource API, connected to JDBC driver B via XA resource API, and JDBC driver B interacts with resource manager. JDBC driver B is connected to application server physical XA connection B1 here. And here XA resource B, application server is connected to transaction manager via XA resource B1. And here application server is connected to JDBC application via logical connection B1. Here you can see JDBC's high-level architecture. This figure illustrates the high-level architecture of JDBC. You can use JDBC from your Java programs, applications, applets, and Java server pages. Your Java program interacts only with the JDBC API. Sole purpose of JDBC is to read data such as employee records from databases, and write data such as inserting new employee records back to the databases. With JDBC, though, you can do more than writing records. You can more than reading or writing records. You can even read the metadata about tables, views, and other useful objects, such as stored procedures and indexes in databases. For example, using JDBC database metadata, you can find out the name and number of columns for a given table and their associated data types. This information is useful in developing graphical user interface GUI-based applications. According to Sun Microsystems, the JDBC API contains two major sets of interfaces. The first is the JDBC API for application writers. The second is the lower level JDBC Driver API for driver writers. Here you can see applications interacts with JDBC and JDBC interacts with databases. Here Sybase, Oracle, and here MySQL database. Here you can see JDBC's details architecture. The JDBC API does most of the things through the driver manager class, java.sql.driver manager. What is driver manager? It is a connection factory class. In fact, driver manager is the only class that can create database connections. Each database connection is represented by an instance of java.sql.connection. The driver manager uses drivers to create connections. Each vendor, such as Oracle, MySQL, and Sybase, provides a set of drivers. If you refer to JDBC's architecture, you can observe the following fact. Java code calls JDBC library using the java.sql and javax.sql packages. JDBC loads a driver. For example, Oracle driver is loaded using following code snippet: class.forename within bracket and within double quotations oracle.jdbc.driver.oracle driver, and calling class.forename method automatically creates an instance of a driver and registers the driver with the driver manager class. Driver talks to a particular database such as Oracle or MySQL. Note that you can have more than one driver and therefore more than one database. Here if you consider class driver manager, the basic service for managing a set of JDBC drivers. Note the data source interface provides another way to connect to a data source. The use of data source object is preferred means of connecting to a data source. Here you can see Java applications interacts with JDBC API, and JDBC API interacts with driver manager. Driver manager interacts with JDBC driver here, and the JDBC driver interacts with MySQL here and Oracle database here. And here driver manager interacts with JDBC ODBC bridge, and JDBC ODBC bridge interacts with JDBC ODBC driver. ODBC driver interacts with Microsoft Access database. Here you can see an application, Java application using JDBC components. This figure illustrates how a Java application uses JDBC to interact with one or more relational databases such as Oracle and MySQL without knowing about underlying JDBC driver implementations. This figure exposes the core JDBC classes or interfaces that interacts with Java JDBC applications. Who provides these JDBC drivers? Usually a database vendor such as MySQL, Oracle, Sybase, so on, writes a JDBC driver, a specific software for a specific database, which is a set of classes and interfaces, classes or interfaces that implement these interfaces, such as java.sql.driver for a particular database system. Following the JDBC architecture, Java database application uses the driver manager class to get java.sql.connection object, which represent a database connection. Then using a connection object, you can create statement, prepared statement or callable statement, which can execute SQL queries and store procedures and return results as a result set object. Result set is a table of data representing a database result set, which is usually generated by executing a statement that queries the database. The JDBC API is comprised of two Java packages, java.sql and javax.sql. The following core JDBC classes and classes, interfaces and exceptions in the java.sql package. Driver manager. This class loads JDBC drivers in memory. You can use it to create java.sql.connection objects to data sources such as Oracle, MySQL and so on. Connection. This interface represents a connection with the data source. You can use connection object for creating statement, prepared statement and callable objects. Statement. This interface represents a static SQL statement. You can use it to retrieve results, retrieve a result set. Objects. Prepared statement. This interface extends statement and represent a precompiled SQL statement. You can use it to retrieve result set objects. Callable statement. This interface represents database stored procedures. A database stored procedure. You can use it to execute stored procedures in a database server. Result set. This interface represents a database result that database result set generated by using SQL select statement. SQL exception. This class is an exception class that provides information on database access error or other errors. Here the interface result set. A table of data representing a database result set, which is usually generated by executing a statement that queries the database. Interface statement. The object used for executing a static SQL statement and returning the result it produces. Interface prepared statement. An object that represents a precompiled SQL statement. Interface callable statement. The interface used to execute SQL stored procedures. The JDBC API provides a stored procedure SQL escape syntax that allows stored procedures to be called in a standard way for all RDBMSs. This escape syntax has one form that includes the result parameter and one that does not. If used, the result parameter must be registered as an out parameter. The other parameter can be used for input, output, or both. Parameters are referred to sequentially by number, with the first parameter being 1. Interface connection. A connection session with a specific database. SQL statements are executed and results are returned with the context of a connection. Class Driver Manager, the basic service for managing a set of JDBC drivers. Note, the data source interface provides another way to connect to a data source. The use of a data source object is preferred means of connecting to a data source. Here the driver manager is connected to Oracle driver, manager is connected to drivers, and here Oracle driver and Oracle is connected to Oracle database. Here driver manager interacts with Oracle driver, and Oracle driver interacts with Oracle database. Here driver manager interacts with MySQL driver, and MySQL driver interacts with MySQL database. Here driver manager interacts with JDBC ODBC bridge, and JDBC ODBC bridge interacts with ODBC driver, and ODBC driver interacts with ODBC database. Here driver manager interacts with connection, and connection interacts with statement, prepared statement, and callable statement. Statement, prepared statement, and callable statement interacts with result sets. Here you can see ODBC architecture. An open database connectivity. ODBC is a programming interface from Microsoft that provides a common language for Windows application to access database on a network. ODBC is a C-based interface to a SQL-based database system. It provides a consistent interface for communicating with the database and for accessing database metadata, information about the database system, vendor, and how the tables, views, and data are stored. A client can connect to a database and manipulate it in a standard way. ODBC began as a PC standard, and it has nearly become an industry standard. Vendors provide specific drivers or bridges, the so-called ODBC bridge, to their particular database management system. For example, to access an ODBC-based database system from a Java client, you may use the JDBC ODBC bridge developed by Sun Microsystems and Mirant, now Serena Software. Therefore, you can use the JDBC ODBC bridge to access databases that support ODBC. For example, you can use the JDBC ODBC bridge to access Microsoft Access databases. According to Microsoft ODBC programmer reference, the ODBC architecture has 4 components. Applications performs processing and calls ODBC functions to submit a SQL statement and retrieve result. Driver manager loads and unloads drivers on behalf of an application. Process ODBC function calls or passes them to a driver. Driver processes ODBC function calls, submits submits a SQL request to a specific data source and returns results to the application. If necessary, the driver modifies an application's request so that the request conforms to syntax supported by the associated DBMS. Data source consists of the data the user wants to access and its associated operating system DBMS, and network platform, if any, used to access DBMS. This figure shows an ODBC architecture and relationship between those four components. ODBC is a set of function calls based on the SQL access group SAG function set for utilizing a SQL database system, backend system. The SAG set implements the basic functionality of dynamic SQL. Embedded SQL commands can be translated to a ODBC. With ODBC, Microsoft extended the basic SAG function set to include functions for accessing the database catalog and for controlling and determining the capabilities of ODBC drivers and their sources, backends. Microsoft also has refined and fleshed out the SAG proposal. Microsoft applies the ODBC driver manager for its operating systems, Windows 95, Windows NT. The ODBC driver manager coordinates access to ODBC drivers and their associated data sources. Although SQL is well suited for managing databases, it was not designed to be a general application language. Rather, it was intended to be used only as a means of communicating with databases. Unfortunately, you cannot easily write a program that will run on multiple platforms, even though the database connectivity standardization issue has been largely resolved. For example, if you wrote a database client in C++, you might have to totally rewrite the client for another platform. That is, your PC version would not run on a machine top. There are two reasons for this. First, C++ as a language is not portable because C++ is not completely specified. For example, how many bits does an int data type hold. Second, and more important, the support libraries such as network access and G frameworks are different on each platform. Another problem with ODBC is that its interface is complicated and takes time to learn to use well. JDBC eliminated these problems and introduced a platform-independent solution to a relational database access. Because of its poor performance and lack of transaction support, the JDBC ODBC bridge driver is recommended only for experimental use or when no other alternative is available. Here you can see application is connected to driver manager via ODBC API. Driver manager is connected to drivers via ODBC API. Here drivers are connected to data sources. Here you can see a JDBC ODBC bridge architecture. This figure shows a JDBC ODBC bridge architecture. The JDBC ODBC bridge currently targets straightforward simple applications. It is not meant for complex application with many threads and functional components and with complex program logic during execution. Is the JDBC ODBC bridge driver recommended for commercial applications? According to Sun Microsystems, the JDBC ODBC bridge driver is recommended only for experimental use or when no other alternative is available. Where can you get the JDBC ODBC bridge? The JDBC ODBC bridge is bundled with the Java for example, the earlier version Java 2 SDK standard edition, so there is no need to download it separately. The JDBC ODBC driver class, sun.jdbc.odbc.jdbc driver is included in the Java 2 SDK. This is this is a description from earlier version. How fast is the JDBC ODBC bridge? The JDBC ODBC bridge is not as fast as commercial JDBC drivers such as Oracle or MySQL. Is the JDBC ODBC bridge multi-threaded? No, JDBC ODBC bridge does not support concurrent access from different threads. The JDBC ODBC bridge uses synchronized methods to serialize all the calls it makes to the ODBC layer written in the C programming language. Multi-threaded Java programs may use JDBC ODBC bridge, but they will not get the advantages of multi-threading. Does the JDBC ODBC bridge support multiple concurrent open statements per database connections? No, you can only use one statement object per connection object when you are using JDBC ODBC bridge. Does the JDBC ODBC bridge support all data types? No, it does not support all data types. For example, blob and clob data types are not supported. Here the application communicates with the application. Here the application interacts with JDBC API. JDBC API interacts with JDBC Manager. JDBC Manager interacts with JDBC ODBC Bridge. JDBC ODBC Bridge interacts with ODBC Manager. ODBC Manager interacts with ODBC drivers. And ODBC driver interacts with DBMS server. Here you can see core JDBC classes or interfaces. This figure shows the core JDBC classes or interfaces used to access a database. The core JDBC classes or interfaces are as follows. Java.sql. Driver manager. The major task of the driver manager class is to access JDBC drivers and create java.sql.connection database connection objects. Java.sql.connection. This interface represents a database connection. This is the key for the accessing most of the database objects such as tables, columns, and so on. Java.sql.statement. The connection object creates a statement objects. You can use statement object to execute SQL statement and queries, which produces the result set objects. The result of executing SQL command and queries. Java.sql.prepared statement. A connection object creates prepared statement, parameterized statement objects. You can use the prepared statement object to execute SQL statement and queries, which produce result set objects. The result of executing SQL statement and queries. Java.sql.callable statement. The connection object creates a callable statement. Statement used to execute stored procedures objects. You can use prepared statement objects to execute SQL statement. And queries, which produces result set object. The result set executing SQL statement and queries. The callable statements. The Java.sql.result set. The result set of a SQL query is returned via a result set object. The table of data representing a database result set, which is usually generated by executing a statement that queries the database. Class driver manager in package SQL java.sql in module java.sql. The base service for managing a set of JDBC drivers. Note the data source interface provides another way to connect to a data source. The use of data source object is preferred meanings of connecting to a data source. Interface connection in package java.sql in module java.sql. A connection session with a specific database. The SQL statements are executed and results are returned within the context of a connection. Interface statement, the object used for executing a static SQL statement and returning the result it produces. Interface prepared statement, an object that represents a precompiled SQL statement. Interface callable statement, the interface used to execute SQL stored procedures. The JDBC API provides a stored procedure SQL escape syntax that allows stored procedures to be called in a standard way for all RDBMSs. This escape syntax has one form that includes the result parameter and one that does not. If used, the result parameter must be registered as an out parameter. Other parameters can be used for input, output, or both. Parameters are referred to sequentially by number, with the first parameter being 1. Interface result set, a table of data representing a database result set, which is usually generated by executing a statement that queries the database. Here the one load and register JDBC driver. Here you can see driver manager. Driver manager is connected to connection where to get the connection object from the driver manager. 3 here, create statement, prepared statement or callable statement. Here the connection is connected to statement and prepared statement and callable statement, and here the statement and prepared statement and callable statement are connected to result set via for execute statement, prepared statement or callable statement. Here you can see typical JDBC internet architecture. This figure represents a typical three-tier model. In this model, a client application, for example a browser, communicates with the Java servlet or JSP in a web server, such as Tomcat from the Apache Software Foundation using Hypertext Transfer Protocol HTTP or HTTP over SSL HTTPS. Tomcat is servlet container that is used in the official reference implementation for Java servlet and JSP technologies. Java code servlet or JSP in a web server uses JDBC API to access relational database server. Here you can see a client machine, client browser, client and browser connected to interacts with web server Tomcat via HTTP, RMI, or CORBA, etc. Web server Tomcat interacts with Java servlet or JSP. Java servlet or JSP interacts with JDBC. Web server Tomcat and Java servlet JSP and JDBC are in middle tier machine here. JDBC interacts with DBMS via DBMS protocol. DBMS is in database server machine here. Here you can see the interaction and relationships between key JDBC classes and interfaces. Also, to illustrate the importance of connection object in the java.sql package, this figure shows the interaction and relationship between the key classes and interfaces in the java.sql package. This also shows the method involved in creating statements, setting parameters, setting and retrieving results. For details, please see the final release of the JDBC specification. Here you can see a java.lang.class, the class T. The T in package java.lang and in module java.base. Instances of the class represent classes and interfaces in running Java application. The enum class and a record class are kinds of class. An annotation interface is a kind of interface. Every array also belongs to a class that is reflected as a class object that is shared by all arrays with the same element type and number of dimensions. The primitive data types boolean, byte, char, short, int, long, float, and double, and keywords void are also represented as class objects. The interface driver in package java.sql in module java.sql. The interface that every driver class must implement. Interface data source, a factory for connections to the physical data source that this data source object represent, an alternative to the driver manager facility. A data source object is the preferred means of getting a connection. An object that implements the data source interface will typically be registered with the naming service based on Java naming directory JDBC API. Class driver manager, the basic service for managing a set of JDBC drivers. Note, the data source interface provide another way to connect to a data source. The use of a data source object is preferred means of connecting to a data source. Interface connection, a connection session with a specific database. SQL statements are executed and results are returned within the context of a connection. Interface database metadata, the comprehensive information about the database as a whole. Interface statement, the object used for executing a static SQL statement and returning the results it produces. Interface prepared statement, an object that represents a precompiled SQL statement. Interface callable statement, the interface used to execute SQL stored procedures. The JDBC API provides a stored procedure SQL escape syntax that allows the stored procedure to be called in a standard way for RDBMSs. This escape syntax has one form that includes the result parameter and one that does not. If used, the result parameter must be registered as an out parameter. The other parameter can be used for input, output, or both. The parameters are referred sequentially by a number with the first parameter being 1. Interface result set, a table of data representing a database result set, which is usually generated by executing a statement that queries the database. Result set, interface result set metadata, an object that can be used to get information about the data types and properties of a columns in a result set object. Here the driver manager is connected to the connection via get connection. Here java.lang class, lang.class is connected to driver via new instance, and driver is connected to connect the connection via connect. And here javax.sql.data source is connected to connection via get connection. Here the connection is connected to statement via create statement. Statement is connected to result set via execute query. Here the connection is connected to prepared statement via prepared statement. Prepared statement is connected to the result set via execute query. And here connection is connected to callable statement via prepare call, and callable statement is connected to the result set via result set. And here statement is connected to prepared statement via subclass, and prepared statement is connected to callable statement via subclass. And here the result set is connected to result set metadata via get, and here result set is connected to data types via get xxx, and data type is connected to prepared statement via input, and here callable statement interacts with data types via input to output. Here you can see JDBC life cycle. Class driver manager in package java.sql in module java.sql. The basic service for managing a set of JDBC drivers. Note the data source interface provides another way to connect to a data source. User data source object is the preferred means of connecting to a data source. Interface connection. A connection session with a specific database. SQL statements are executed and results are returned within the context of the connection. Interface statement. The object used for executing a static SQL statement and returning the results to its producers. Interface result set. The table of data representing a database result set, which is usually generated by executing a statement that queries the database. Here 0, the load database driver. Here step 1 is get connection, and driver manager is connected to the connection via get connection here. And here step 2 create statement method. Connection is connected to statement via create statement. Here 3a select execute query, and here statement is connected to result set via execute query. 3b insert update or delete execute update here. And here step 4.1 result set is connected to itself via next method here. Here step 2 result set is connected to data via get xxx. Here step 4b int, and here the step 5 is result set is closed here, and here connection close, and step 5 here statement close. Here you can see folder structure in create database example in JDBC MySQL. Here the complete folder structure of a sample project is shown here. Here DB query has source and JRE system library and MySQL connector Java 5.1.14 bin.jar. and source includes com dot the open tutorials dot JDBC DAO, and it has a database DAO.java here, and here the source contain com dot the open tutorials dot JDBC DB and com dot open tutorials JDBC exception and com dot open tutorials dot JDBC main, and here the com dot open tutorials dot JDBC DB package contains connection factory.java and dbutil.java. Here the com dot open tutorials dot JDBC dot exception contains application exception Java, application exception dot Java. Here com dot the open tutorials dot JDBC main contain dbdemo.java. Now we are focusing on Java application. The Java application, the application written in the Java programming language is responsible for interacting with the user and for invoking JDBC API functions. These API functions submit SQL statements for processing by a file system or a database management system. The Java application uses interfaces, classes, and methods that are defined by the Java API to access data source. Here you can see Java and the database. JDBC is a SQL level API, one that allows you to execute SQL statements and retrieve the results, if any. API itself is a set of interfaces and classes that designed to perform actions against any database. The interface result set, a table of data representing a database result set, which is usually generated by executing a statement that queries the database. Interface statement, the object used for executing a static SQL statement and returning the result it produces. By default, only one result set object per statement object can be open at the same time. Therefore, if the reading of one result set object is interleaved with the reading of another, each must have been generated by different statement objects. All execution methods in the statement interface implicitly close a current result set object of the statement if an open one exists. Interface prepared statement, an object that represents a precompiled SQL statement. A SQL statement is precompiled and stored in a prepared statement object. This object can then be used to efficiently execute this statement multiple times. Interface callable statement, the interface used to execute SQL stored procedures. The JDBC API provides a stored procedure SQL escape syntax that allows stored procedures to be called in a standard way for all RDBMSs. This escape syntax has one form that includes a result parameter and one that does not. If used, the result parameter must be registered as an out parameter. The other parameters can be used for input, output, or both. Parameters are referred to sequentially by number, with the first parameter being 1. Interface connection. A connection session with a specific database SQL statements are executed and results are returned within the context of a connection. A connection object's database is able to provide information describing its tables, its supported SQL grammar, its stored procedures, the capabilities of this connection, and so on. This information is obtained with the get metadata method. You can see here class driver manager, the basic service for managing a set of JDBC drivers. Here you can see result set is connected to statement. Here result set is connected with connected to prepared statement. Result set is connected to callable statement. Statement, prepared statement, callable statement interacts with the connection. Connection interacts with driver manager. Driver manager interacts with Oracle driver or JDBC or DBC bridge and Sybase driver here. Oracle driver interacts with Oracle database. JDBC or DBC bridge interacts with ODBC driver. ODBC driver interacts with ODBC database. Sybase driver interacts with Sybase database. Here you can see a relationship of the connection to other objects. To illustrate the importance of the connection object, this figure shows how connection objects are created. Class T in package java.lang in module java.base. Instances of the class represent classes and interfaces in a running Java application. An enum class and a record class are kinds of class. An annotation interface is a kind of interface. Every array also belongs to a class that is reflected as a class object that is shared by all arrays with the same element type and number of dimensions. The primitive data types boolean, byte, char, short, int, long, float, and double, and the keyword void are also represented as class objects. Interface driver in package java.sql in module java.sql. The interface that every driver class must implement. class driver manager, the basic service for managing a set of JDBC drivers. Note the data source interface provides another way to connect to a data source. The use of a data source object is the preferred means of connecting to a data source. The interface data source in package javax.sql, a factory for connections to the physical data source that this data source object represents. An alternative to the driver manager facility, the data source object is the preferred means of getting a connection. An object that implements the data source interface will typically be registered with the naming service based on the Java naming and directory JNDI API. Interface connection in package java.sql in module java.sql. A connection session with a specific database. SQL statements are executed and results are returned within the context of a connection. Interface statement in package java.sql in module java.sql. The object used for executing a static SQL statement and returning the results it produces. Interface prepared statement in package java.sql in module java.sql. An object that represents a precompiled SQL statement. The interface callable statement in package java.sql in module java.sql. The interface used to execute SQL stored procedures. The JDBC API provides a stored procedure SQL escape syntax that allows stored procedures to be called in a standard way for all RDBMSs. This escape syntax has one form that includes the result parameter and one that does not. If used, the result parameter must be registered as an out parameter. The other parameters can be used for input, output, or both. Parameters are referred to sequentially by number, with the first parameter being 1. Here the java.lang.class is connected to driver via new instance. Here the driver is connected to connection via connect. Here driver manager is connected to connection via get connection. Here the javax.sql.data source is connected to connection via get connection. Here the connection is connected to statement via create statement. Here the connection is connected to prepared statement via prepared statement. Here the connection is connected to callable statement via call. Here statement is connected to prepared statement via subclass, and prepared statement is connected to callable statement via subclass. Here you can see a relationship of result set to other classes and interfaces, classes or interfaces. To show how the importance of the result set object, this figure shows the interfaces and relationships between the key classes and interfaces in the java.sql package. The figure also shows the methods involved in creating statements, setting parameters, and retrieving results. For details, please use the final release of the JDBC specification. As you can observe from the low-level class or interface relationships, To connect to a relational database, you must use an instance of the connection object. To get the connection object, you need to provide database URL, username and password. Then to find out the names of the database views, tables and columns, so-called metadata. You need to get an instance of database metadata. Database metadata object from the connection object. Next, to issue a SQL query, you compose the SQL query string and use the connection object to create statement object. By executing the statement, you obtain the results result set object. And to find out names of the column rows in the result set, you need to obtain the instance of the result set metadata object. Interface connection in package java.sql in module java.sql. A connection session with a specific database. SQL statements are executed and results are returned within the context of a connection. Interface database metadata. Comprehensive information about the database as a whole. Interface statement, an object used for executing a static SQL statement and returning the results it produces. Interface prepared statement, an object that represents a precompiled SQL statement. Interface callable statement, the interface used to execute SQL stored procedures. The JDBC API provides a stored procedure SQL escape syntax that allows stored procedures to be called in a standard way for all RDBMSs. This escape syntax has one form that includes the result parameter and one that does not. If used, the result parameter must be registered as an output parameter, and the other parameter can be used for input, output, or both. Parameters are referred to sequentially by number, with the first parameter being 1. Interface result set, a table of data representing a database result set, which is usually generated by executing a statement that queries the database. Interface result set metadata, an object that can be used to get information about the types and properties of the column in result set objects. The following code fragment result set of objects. Here you can see the connection. Connection is connected to database metadata via get, and here connection is connected to statement via create statement. Here connection is connected to prepare statement via prepare statement, and connection is connected to callable statement via prepare call. And here statement is connected to result set via execute query, and prepare statement is connected to result set via execute query, and callable statement is connected to result set via execute query, and result set is connected to result set metadata via get, and here result set is connected to data types via get xxx, and data types is connected to prepare statement via input, and callable statement interacts with data types via input to output. Here statement is connected to prepare statement via subclass, and prepare statement is connected to callable statement via subclass. Here you can see steps to design JDBC applications in Java. In this article, we are going to discuss the steps to design JDBC applications in Java with Java. Let us understand how to perform crude operations in Java application using JDBC step by step. This diagram shows the different steps required to develop a JDBC application in Java. Let us discuss each step in detail. Establishing connection. In the JDBC programming model, the first step is to establish the connection between the Java application and the database server. Establishing the database connection in Java program involves two steps. Step 1, loading JDBC driver from secondary memory into primary memory. First, you need to load the driver or register it before using it in the program. Registration is to be done once in your program. In java.lang.class, there is a static method for name. This method is used to load JDBC driver into application process space. You can register the driver by following two ways. One, class.forName, driver class name. Here we load the driver's class file into memory at runtime. No need of using new or create an object. Two, driver manager.register driver method. Driver manager is a Java inbuilt class with a static member register. Here we call the constructor of the driver class at the compile time. When the forName method is successfully executed, three things happen in the background. 1, the driver class is loaded into memory. 2, the driver class object is created. 3, the driver class is registered with the driver manager. Step 2, requesting for a connection object. In order to establish a communication with the database, you must first open a JDBC connection to the database. After loading the driver, establish a connection. In java.sql.driverManager class, there is a static method getConnection. This method is used by the Java program to request the database connection. Following three methods of following are the three methods of driverManager.getConnection. 1, getConnection string URL. 2, getConnection string URL properties prop. 3, getConnection string URL, string user, string password. Once the statement is executed, the client connects to the database server object. The object oriented representation of JDBC client session with the database server is nothing but java.sql.connection object. Note, internally getConnection method call connect method of connection class. Creating statement object. Once the connection is established, you can interact with the database. The create statement method of the connection interface is used to create a statement. The object of the statement is responsible to execute queries with the database. The statement object is designed to submit SQL statement from JDBC client to the DBMS via JDBC driver. Submitting the SQL statement. Now it is time to process the result by executing the query. The java.sql.statement object has two important methods to submit SQL statement to DBMS. 1, execute update string DML. The execute update string query method of the statement interface is used to execute queries of updating or inserting. This method is used to submit DML, insert, update or delete SQL statement. 2, execute query string DRL. The execute query method of the statement interface is used to execute queries to the database. This method returns the object of result set that can be used to get all records of a table. This method is used to submit the select statement. Close the connection. So finally we have to send the data to the specified location by closing the connection object statement, and the result set will be closed automatically. The close method of the connection interface is used to close the connection. Here you can see establish connection is connected to create statement object. Create a statement object is connected to submitting the SQL statement. Submitting the SQL statement is connected to processing and presenting of the request. Here processing and presenting of the request is connected to one or more CRUD operation. If it is yes, it's connected to submitting the SQL statement, and if it is no, then it's connected to closing the statement. Closing the statement is connected to closing the connection. As an example, we can consider here Java database connectivity. Java database connectivity, JDBC API. The Java database connectivity JDBC API provides universal data access from the Java programming language. Using the JDBC API, you can access virtually any data source, from relational databases to spreadsheets and flat files. JDBC technology also provides a common base on which tools and alternative interfaces can be built. Packages include java.sql, javax.sql. As example 2, we can consider module java.sql defines the JDBC API. Here you can see the module graph. Java.sql here you can see Java.sql module. This module exports Java.sql package and javax.sql package. Indirect exports java.util.logging package from java.logging module. javax.transaction.exe package from java.transaction.exe module, and javax.xml, javax.xml.catalog, etc. from java.xml package, our java.xml module. So java.sql module requires java.logging module defines the Java logging API, and java.sql module requires java.sql xml module defines the Java API for XML processing, JAXP, the streaming API for XML, STAX, the simple API for XML, SAX, and the W3C document object model, DOM API. And Java.xql module requires java.transaction.xa module, defines an API for supporting distributed transactions in JDBC. Java.logging and Java.xml and Java.transaction.xa modules requires Java.base module, defines the defines the foundational APIs of the Java SE platform. As an example 3, we can consider package java.sql, provides the API for accessing and processing data stored in a data source, usually a relational database, using the Java API, Java programming language. This API includes a framework whereby different drivers can be installed dynamically to access different data sources. Although the JDBC API is mainly geared to passing SQL statements to a database, it provides for reading and writing data from any data source with a tabular format. The reader-writer facility available through the javax.sql.rosette group of interfaces can be customized to use and update data from a spreadsheet, flat file, or any other tabular data source. This package is in module java.sql. This package, the java.sql package contains APIs for the following: making a connection with the database via the driver manager facility, includes a driver manager class, SQL permission class, driver interface, driver property info class. Sending SQL statement to a database, statement, prepared statement, callable statement, connection, interface, and save point. Next point is retrieving and updating the results of a query, result set interface. Next point is standard mappings for SQL types to classes and interfaces in the Java programming language. Array interface, blob interface, club interface, date class, enclub interface, ref interface, row ID interface, struct interface, SQL XML interface, time class, timestamp class, and types class. Next point is custom mapping and SQL user defined type UDT to a class in the Java programming language, SQL data interface, SQL input interface, and SQL output interface. Next point is metadata, database metadata interface, result set metadata interface, and parameter metadata interface. Next point, the last point is exceptions, SQL exception, SQL warning, and batch update exception. As an example 4, we can consider the module, the package javax.sql provides the API for server-side data source access and processing from the Java programming language. This package supplements the java.sql package, and as of the version 1.4 release is included in the Java Platform Standard Edition Java SE. It remains an essential part of the Java Platform Enterprise Edition Java EE. This package is in the module java.sql. The javax.sql package provides for the following. 1. The data source interface as an alternative to the driver manager for establishing a connection with the data source. 2. Connection pooling and statement pooling. 3. Distributed transactions. 4. Row sets. Applications use the data source and row set APIs directly, but the connection pooling and distributed transactions APIs are used internally by the middle tier infrastructure. As an example 5, we can consider this code segment. Here you can see a interface connection, a connection session with a specific database. SQL statements are executed and results are returned with the context of a connection. Interface statement, the object used for executing a static SQL statement and returning the results it produces. Here in create statement, creates a statement object for sending SQL statements to database. Here the execute query method execute the given SQL statement, which returns a single result set object. Here the result set interface, a table of data representing a database result set, which is usually generated by executing a executing a statement that queries the database. Here the next moves the cursor forward one row from its current position, and here the get int retrieves a value of a designated column in a current row of this result set object as an int in the Java programming language. In get string retrieves the value of the designated column in the current row of this result set object as a string in the Java programming language. Here get float retrieves the value of the designated column in the current row of the of this result set object as a float in the Java programming language. In the following example, of setting a parameter, con represents an active connection. The interface prepared statement, an object that represents a precompiled SQL statement. We can consider this code segment as example 7. STMT is the callable statement. Here the interface callable statement, the interface is used to execute SQL stored procedures. The JDBC API provides the stored procedure SQL escape syntax that allows stored procedure to be called in a standard way for RDBMS. This escape syntax has one form that includes a result parameter and one form does not. If used, the result parameter must be registered as an out parameter. The other parameters can be used for input, output, or both parameters. Parameters are referred to sequentially by number, with the first parameter being 1. Here the register the out parameter before calling the stored procedure. They read the out parameter now. Now we are considering connections. A connection object represents a connection to a data source via a JDBC technology enabled driver. Here the interface connection in package java.sql in module java.sql. A connection session with a specific database. SQL statements are executed and results are returned within the context of a connection. The data source can be a DBMS, a legacy file system, or some other source of data with the corresponding JDBC driver. A single application using JDBC API may maintain multiple connections. These connections may access multiple data sources, so they may all access a single data source. From the JDBC perspective, a connection object represents a client session. It has associated state information such as user ID, a set of SQL statement and results sets being used in that session, and what transaction semantics are in effect. To obtain the connection, the application may interact with either a driver manager class working with one or more driver implementation or a data source implementation. Using data source objects is the preferred method because it enhances application portability, it makes code maintenance easier, and it makes it possible for the application to transparently make use of connection pooling and distributed transactions. All Java EE components that establish a connection to a data source use a data source object to get a connection. Now we are considering transaction boundaries and auto commit. We are considering disabling auto commit mode in transaction boundaries and auto commit in transactions. This code example shows how to disable auto commit mode. The method set auto commit boolean auto commit in interface connection in package java.sql in module java.sql sets this connections auto commit mode to the given state. If the connection is in auto commit mode, then all its SQL statement will be executed and committed as individual transactions. Otherwise, its SQL statements are grouped into transactions that are terminated by a call to either the method commit or the method rollback. By default, new connections are in auto commit mode. Here the setting auto commit off. When auto commit is disabled, each transaction must be explicitly committed by calling the connection method commit or explicitly rollback by calling the connection methods rollback respectively. This is appropriate for cases where transaction management is being done in a layer above the driver, such as when the application needs to group multiple SQL statements into a single transaction, when the a transaction is being managed by the application server. The default for auto commit mode to be enabled when the connection object is created. If the value of the auto commit is changed in the middle of a transaction, the current transaction is committed. If the auto commit is called and value for auto commit is not changed from its current value, it is treated as no op. It is an error to enable auto commit for a transaction for a connection participating in a distributed transaction. Here the assume con is a connection object. Now we are considering two-phase commit in transaction management in distributed transactions. Here you can see the starting and ending transaction branches using XA resource interface. The following steps outline how a transaction manager uses XA resource objects to implement the two-phase commit protocol. These steps assume a three-tier architecture where an application server is working with an external transaction manager. The application server step one, the application server gets XA resource objects from the two different connections. Here the getting XA resource object from XA connection. Step 2, the application server passes XA resource objects to the transaction manager. The transaction manager does not access the associated XA connection object directly. Step 3, the transaction manager uses XA resource objects to assign a piece of transaction to each of the associated resource managers. The transaction is identified by XID, which represents the identifier generated by the transaction manager when the transaction is created. Here you can see the starting and ending of the transaction branches using XA resource interface. Step 4, the transaction manager initiates the two-phase commit protocol by asking each participant to what. Here the initiating two-phase commit. A participating resource manager can vote to rollback transaction by throwing java x.transaction.xa.xa exception. Step 5, both participant vote to commit. The transaction manager tells each one to commit its piece of the distributed transaction. The second parameter tells the resource manager not to use the one-phase commit protocol on behalf of XID. Here the committing the database, committing the distributed transaction here. Step 6, if the resource manager wants to roll back, the transaction manager tells each one to roll back its piece of transaction. Here you can see the rollback, the distributed transaction. Transaction manager is not required to use the same XA resource object to commit or rollback. Commit to rollback a transaction branch as was used to execute the branch. If a different XA resource object are used, however, they must be associated with the XA connection objects that connects to the same resource manager. Note these steps also apply to the case where XA con A and XA con B are physical connection to the same resource manager. Here the XA con A connects to a resource manager A. Here the XA con B connects to a resource manager B. Here the send to resource manager A send work to resource manager A. The TM and all TM no flags argument indicates we are starting a new branch of transaction, not joining or resuming an existing branch. Do do work with resource manager A. Tell the resource manager A that it's done and no errors found. Now no errors have occurred. Do work with the resource manager B. B is part of the distributed transaction. Now we are considering creating statements in statement interface. In the statements. Here the creating multiple statement object from a single connection. Module the interface is statement in package java.sql in module java.sql. The object used for executing a static SQL statement and returning the results it produces. Statement objects are created by connection objects, as it is done in connection objects. Each connection objects can create multiple statement objects that may be used concurrently by a program that is demonstrated in this code example. Here the get a connection from the data source object ds. Here create two instances of statements. Now we are considering statements in description of batch updates in batch updates. Here creating and executing a batch of insert statements. The batch update facility allows statement objects to submit a set of heterogeneous SQL statements together as a single unit or batch to the underlying data source. Since the JDBC 2.0 API, a statement object has had the ability to keep track of a list of commands or batch that can be submitted together for execution. When a statement object is created, its associated batch is empty. An application adds a command to the statement batch one at a time by calling the method statement.add batch and providing it with the SQL statement to be added. Any of the commands added to the batch must return a simple update count and must not return a result set. If an application decided not to submit a batch command that has been constructed for a statement, it can call the method statement.clearBatch to clear the batch of all commands. This in this code example, all the SQL statement required to insert a new employee into a fictitious company web database are submitted as a single batch. In the example, autocommit mode is disabled to prevent the driver from committing the transaction when statement.execute batch is called. Disabling autocommit allows the application to decide whether or not to commit the transaction in the event that an error occurs and some of the commands in the batch cannot be processed successfully. For this reason, autocommit should always be turned off when batch updates are done. The commit behavior of execute batch is always implementation defined when an error occurs and autocommit is true. It is not possible to set a save point within a batch statements to enable partial recovery. If a save point is set any time before the method execute batch is called, it is set before any of the statements that have been added to the batch are executed. Although the focus of this section is on using statement objects to do the batch updates, you can have a separate discussion that follows applies to prepared statement and callable state objects as well. Note, if your database supports returning an update count that may exceed the integer max underscore value, use the method execute large batch. Here the turn off autocommit. Submit a batch of update commands for execution. Now we are considering creating result set objects in creating and manipulating result set object in result sets. Here executing a query returning a result set object. The interface result set in package java.sql in module java.sql, a table of data representing a database result set, which is usually generated by executing a statement that queries the database. The result set objects is most often created as the result of executing a statement object. The statement methods execute query and get result set both returns the result set objects. Do various database metadata methods. This code example execute SQL statements returning a result set object. Here the executing a query returning result set object. For each for each book in the table book list, the result set object will contain row consisting of 3 columns: author, title, and ISBN. Now we are considering creating blob, club, and n-club objects in blob, club, and n-club objects in advanced data types. Here, creating and writing bytes into a blob object. The connection interface provide support for creation of blob, club, and n-club objects using methods create blob, create club, and create n-club. The objects that is created does not contain any data. Data may be added to the object by calling one of the set xxx methods in the blob, club, or n-club interface. In this code example, the method connection.create blob is used to create an empty blob object. Blob.set bytes is used to write data to a blob object. Here you can see creating and writing bytes to blob objects. Now we are considering type mapping in customized date type mapping. Here putting an entry in a connections type map. The method void set type map string class map in interface connection in package java.sql and in module java.sql. Install the given type map object as the type map for this connection object. The type map will be used for connection for the custom mapping of SQL structured type and distinct types. The SQL user defined types UDTs and structured type and distinct types can be given a custom mapping to a class in the Java programming language. The default is the driver to use the default mapping between SQL data types and types in the Java programming language. The default mapping for an SQL structured type is to the interface struct. The default mapping for an SQL distinct type is to the type to which the underlying type is mapped. If the custom mapping has been set up for a UDT, the driver will use the custom mapping instead of the default mapping when an application calls the get object or set object. methods on that UDT. Setting up a custom mapping requires two things. One, writing implementation of SQL data interface for UDT. This class typically maps the attributes of a SQL structured type or a single attributes of the distinct type to fields. There is, however, great latitude allowed in how UDT is custom mapped. It is expected that most SQL data implementations will be creating using a tool. 2. Putting an entry in a Java util.map object. The entry must contain the following two items: a fully qualified name of the SQL UDT that is to be mapped. B. The class object for SQL data implementation. It is an error if the class listed in a type map entry does not implement the SQL data interface. For example, if the UDT name mySchemeName.authors and the SQL data implementation is the class authors, the entry for the type map associated with the connection object con would be like this code example. Here the putting an entry in connection type map. The method connection.getTypeMap returns the type map associated with the connection object CONN. The method connection.setTypeMap sets the given java.util.map object as the type map for CONN. When a SQL value with the custom mapping is being retrieved by the method resultSet.getObject or callable statement.getObject or any other methods that materialize the SQL values data on the client, the driver will check to see if there is an entry in the connections type map for the SQL value that is to be retrieved. If there is, the driver will map SQL UDT to the class specified in the type map. If there is no entry for UDT in the connection type map, the UDT is mapped to the default mapping. Certain methods may take a type maps as a parameter. A type map supplied as a parameter supersedes the type map associated with the connection. A UDT that does not have an entry in the type map supplied as a parameter will be mapped to the default mapping. When a type map is explicitly supplied to the method, the connections type map is never used. Now we are considering system contracts in relationship to connectors. The following standard contracts are defined between an application server and a data source system. A connection management contract that enables application components to connect to a data source. A connection management contract is equivalent to the services distributed by the JDBC interfaces, data source and connection pool data source. A connection management contract between transaction manager and a data source supporting transactional access to its resources. The transaction contract is equivalent to the services described by the JDBC interface X data source. A security contract that enables secure access to a data source. The security contract does not have an equivalent in the JDBC API. Authentication in the JDBC API always consists of providing a username and a password. A system contract defined in the contract specification describes the interface between an application server and one or more resource adapters. This interface allows the resource adapters to be bundled in such a way that it can be used by any application server that supports the system contracts. The JDBC specification does not make distinction between an application programming interface API and the SPI. However, a driver can map the JDBC interfaces in the SPI to the connector system contracts. Now we are considering isWrapper4 method in wrapper interface, methods in wrapper interface. The interface wrapper in package java.sql in module java.sql. The interface for JDBC classes which provide the ability to retrieve the delegate instance when the instance in question is in fact a proxy class. The isWrapper4 method can be used to determine if the instance implements the specific interface or if the instance is wrapper for an object that does. If the object implements the specified interface, then the value of true is returned. If the instance is a wrapper, then the method isWrapper4 is recursively called on the wrapper object. If the instance does not implement the interface and is not a wrapper, a value of false is returned. This method should implement a low cost operation compared to calling unwrap method. If the isWrapper4 method returns true, then the calling unwrap method with the same interface must succeed. This code example provides an example of using the wrapper interface methods. Here the using isWrapper and unwrap methods. Now we are considering JDBC types mapped to Java types in data type conversion tables. Here the JDBC type char and the Java type, the matching Java type is a string. Now we are considering numeric function in Scala functions. The function name abs number. The function returns absolute value of number. As an exception example, we can consider SQL exception. The class SQL exception, an exception that provides information on a database access error or other errors. This is in the module java.sql and in the package java.sql. Now here we are considering navigating a SQL exceptions in exceptions. The following code segment demonstrate how an application could navigate SQL exceptions and their causes. The class SQL exception in package java.sql in module java.sql, an exception that provides information on a database access error or other errors. It is possible that during the execution of a SQL statement that one or more exception could occur, each with their own potential causal relationship. This means that when the JDBC application catches a SQL exception, there is a possibility that there may be additional SQL exceptions chained to the original thrown SQL exception. To access the additional chain SQL exceptions, an application would recursively invoke get next exception until a null value is returned. The SQL exception may have causal relationship which consists of one or more throwables which caused the SQL exception to be thrown. You may recursively call the method SQL exception .getClose until a null value is returned to navigate the chain of causes. The following code segment here demonstrate how an application could navigate SQL exception and their causes. Here navigating SQL exception and their causes. As an error example, we can consider JDBC connection errors in the environment with IBM Netcool Omnibus. The description is connection errors are typically caused by incorrect or invalid connection with string parameters such as invalid hostname or database name. The action is to verify that you are using correct and valid connection string parameters for the get.jdbc.url property. Now we are focusing on JDBC driver manager, the basic service for managing a set of JDBC drivers. Note, the data source interface provides another way to connect to a data source. The use of a data source object is the preferred means of connecting to a data source. Here you can see driver manager manages connection to DBS. What's the function of the driver manager class? Here in a nutshell, the driver manager class manages connections to databases. According to JDK 1.4, the old version, the driver manager provides the basic service for managing a set of JDBC drivers. As part of its initialization, the driver manager class will attempt to load the driver classes referenced in the JDBC.driver system property. This allows a user to customize JDBC drivers used by their applications. JDBC.drivers equal org.git gjt.mm.mysql.driver oracle.jdbc.driver.oracle driver. For example, note that the drivers are separated by a colon. Here, a program can also explicitly load JDBC drivers at any time. For example, following example loads MySQL and Oracle drivers. For example, a class.forename within bracket and within quotations org.gjt.mm.mysql.driver. The other one is a class.forename within brackets and within double quotations jdbc.driver.oracle driver. When get connection method is called, the driver manager will attempt to locate the suitable driver from among those loaded at initialization and those loaded explicitly using the same class loader as the current applet to application. This figure illustrates the function of the driver manager class. The driver manager class manages the JDBC drivers in the system. It maintains a registry of drivers and locates the appropriate driver to handle a JDBC URLs. On startup, the driver manager loads all the managers specified by the system property JDBC.drivers. The value of this property should be a colon separated list of fully qualified driver class names. You can load additional drivers at any time by simply loading the driver class with class.forename string driver class name. The driver should automatically register itself in a static initialization. Here, database application interacts with driver manager. A driver manager interacts with here, for example, Sybase driver, Oracle driver, MySQL driver. Here, Sybase driver interacts with Sybase database. Here, Oracle driver interacts with Oracle database. Here, MySQL driver interacts with MySQL database. As an example, we can consider class driver manager. The basic service for managing a set of JDBC drivers, not the data source interface, provide another way to connect to a data source. The use of a data source object is the preferred means of connecting to a data source. This is in the module java.sql and package java.sql. As a part of the initialization, the driver manager class will attempt to load available JDBC drivers by using point 1, the JDBC.drivers system property, which contains a colon separated list of fully qualified class names of JDBC drivers. Each driver is loaded using the system class loader. The point 2, system providers of the java.sql.driver class that are loaded via the service provider loading mechanism. As an example 2, we can consider this code segment. Register by using a system property. Each virtual machine has its own method of setting system properties. For example, the Java command from the JDK uses the -d option to set system properties. To set the driver using system properties, specify this following here. This is the fully qualified class names class name of the JDBC driver here, com.ibm.as400.access.as400 JDBC driver here. As an example 3, we can consider this code segment. Register by using the Java program to load IBM toolbox for Java JDBC driver. Add the following to the Java program before the first JDBC call. Here the method public static class question mark and the for name string class name throws class not found exception. This returns the class object associated with the class or interface with the given string name. Invoking this method is equivalent to class for name class name through current loader, where current loader denotes the defining class loader of the current class. For example, following code segment returns the runtime class descriptor for the class name java.lang.thread here. A call for the for name x causes the class name x to be initialized. As an example 4, we can consider this one, this code segment, registering JDBC driver. You can explicitly register the IBM toolbox for Java JDBC driver by using following. The method public static void register driver throws SQL exceptions, registers the given driver with the driver manager. A newly loaded driver class should call the method register driver to make itself known to the driver manager. If the driver is currently registered, no action is taken. As an example 5, we can consider this code segment, connecting to the server database and specifying user ID and password. The method public static connection get connection string URL string user string password attempts to establish a connection to a given database URL. The driver manager attempts to select an appropriate driver from the set of registered JDBC drivers. Note, if the user or password property are also specified as part of the URL, it is implementation defined as to which value will take precedence. For maximum probability or maximum portability, an application should only specify a property once. Now we are considering the driver manager class. This code illustrates how a JDBC client obtains a connection from the driver manager. The class driver manager is in package java.sql in module java.sql, the basic service for managing a set of JDBC drivers. The driver manager class works with the driver interface to manage the set of drivers available to the JDBC client. When a client requests a connection and provides a URL, the driver manager is responsible for finding the driver that's recognized in the URL and using it to connect to the corresponding data source. Key driver manager methods include register driver. This method adds a driver to the set of available drivers and is invoked implicitly when a driver is loaded. The register driver method is typically called by the static initializer provided by each driver. Get connection. The method the JDBC client invokes to establish a connection. This invocation includes the JDBC URL, which the driver manager passes to each driver in its list until it's finds one. Those driver.connect method recognizes the URL. That driver returns a connection object to the driver manager, which in turn passes it to the application. The format of JDBC URL is JDBC subprotocol subname, where subprotocol defines the kind of database connectivity mechanism that may be supported by one or more drivers. The content of and syntax of the subname will depend on the subprotocol. Note, a JDBC URL is not required to fully adhere to the URI, since URI syntax as defined in the RFC 3986 Uniform Resource Identifier URI generic syntax. This code example illustrates how a JDBC client obtains a connection from the JDBC driver, from the JDBC driver manager. Here the loading a driver and getting a connection using driver manager. The driver manager class also provides two other get connection methods. Get connection string URI that connecting to data sources that do not use username and password. Get connection string URI java.util.properties prop, which allows a client to connect using a set of properties describing the username and password along with any additional information that may be required. The driver property info class provides information on the properties that the JDBC drivers can understand. See the JDBC API specification for more details. Here the setup arguments for the call to the get connection method. Subprotocol Derby in the driver URL indicates the use of the Derby JDBC driver. Get connection from the first driver in the driver manager list that recognizes the URL JDBC Derby sample. The call to get connection will also load the driver if needed. When the driver is loaded, an instance of the driver is created and the register driver method is also called to make the driver available to a client. As an exception example, you can consider SQL exception. If a database access error occurs or the URL is null in method public static connection get connection string in class driver manager. As an error example, we can consider this one: invalid JDBC URL JDBC :MySQL Aurora false chat y dash Aurora .xxxx.com :3306 / some DB name here, and URL prefix must be JDBC :JD // Now we are considering data source. A data source is a Java object that implements the javax.sql.data source interface. The data sources offer a portable and vendor independent method for creating JDBC connections. Data sources are factories that return JDBC connection to a database. J2EE applications use JNDI to look up data source objects. Here in JDBC Architecture, JDBC Architecture type 1 drivers, you can see the data source here. Data source interact with JDBC API and JDBC or DBC bridge type 1 driver here. In type 2 drivers, you can see the data source here. Data source interacts with JDBC API and native API partly Java type 2 driver here. In type 3 drivers, you can see data source here. Data source interacts with JDBC API and net protocol all Java type 3 driver here. In type 4 drivers, you can see data source here. Data source interacts with JDBC API and native protocol all type 4 driver. Here you can see JDBC data source. What is JDBC data source? Here enable database connectivity to be managed by application server and are obtained by applications from the server's JNDI tree. Use dynamic pool of reusable database connections and the scope of data source, system or application. All JDBC configurations must conform to the new WebLogic-JDBC.xxd schema, for example. Here applications interacts with data source via JNDI lookup and get connection and perform SQL. Here the connections are inside pool, and pool and JDBC drivers are pool and JDBC driver are inside the data source, and data source interacts with DB. Here you can see how connection pooling works. And what is a connection pooling? A connection pool is a group of ready-to-use database connections associated with the data source. connection pools are created at, for example, Oracle Web Service Startup, etc. And here how connection pooling works. And benefits of connection pooling. Following are some advantages of connection pooling. Connection time and overhead are saved by using existing database connection. It facilitates easier management because connection information is managed in one location. Number of connections to a database can be controlled. The DBMS can be changed without the application developer having to modify the underlying code. A connection pool allows an application to borrow DBMS connection. Here, application component JNDI and JDBC connection pools are inside managed server. Here, application interacts with the data source B here, data sources here, and components interacts with the data source here, and the data source A, data source B, and data source C are inside here JNDI. And here data source A interacts with JDBC connection pool here, and here data source B interacts with JDBC connection pool here, and here data source C interacts with JDBC connection pool here, and connections are inside JDBC connection pool here, and connections interacts with DBMS here. Here you can see how data source connection pooling is used. Here you can see client and data source and connection here. And here and the here JNDI and connection pools are inside the managed server. Here the step 1 client is connected to managed server via lookup data source. Here the connected to JNDI via lookup data source, and here JNDI is connected to client via return data source, step 2. And here step 3, data source is connected to connection pool via get connection method, and here step 4, connection pool is connected to data source via return connection, and here step 5, connection interacts with DBMS. Here you can see JDBC 3.0 connection pooling architecture. The JDBC 3.0 API provides a general framework with hooks to support connection pooling rather than specifying a particular connection pooling implementation. In this way, third-party vendors or users can implement the specific caching or pooling algorithms that best fit their needs. The JDBC 3.0 API specifies a connection event class and the following interfaces as the hooks for any connection pooling implementation. Connection pool data source, pooled connection event listener. This figure shows the general framework. This is JDBC 3.0 connection pooling architecture. JDBC vendor data source. A JDBC driver vendor must provide the class that implements standard connection pooling data source interface. This interface provides hooks that third-party vendors can use to implement pooling as a layer on top of their JDBC drivers. The connection pool data source interface act as a factory that create pooled connection objects. The JDBC driver the JDBC JDBC driver vendor pool connection. A JDBC driver vendor must provide a class that implements the standard pool connection interface. This interface allows third-party vendors to implement the pooling on top of their JDBC drivers. A pool connection object acts as a factory that creates connection objects. Pool connection object maintains the physical connection to the database. The connection object created by the pool connection object is simply a handle to the physical connection. Pooling vendor data source. The third-party vendor must provide a class that implements the data source interface. This interface is the entry point that allows interaction with their pooling module. The pooling vendors class uses the JDBC driver's pool connection data source object to create pool connections that the pool manages. Pooling vendor connection cache. The JDBC 3.0 API does not specify the interfaces to be used between the data source object and the connection cache. The pooling vendor determines how these components will interact. Usually a connection cache module contains one or multiple classes. In this figure, the pooling vendor connection cache class is used as a simple way to convey this concept. The connection cache module should have a class that implements the standard connection event listener interface. The connection event listener interface received the connection event objects from the pooled connection objects when a connection closes or connection error occurs. When a connection created by the pool connection closes, when a connection created by the pool connection closes, the connection cache module returns the pooled returns the pool connection object to the cache. When an application makes a connection by calling dataSource.getConnection on a pooling vendor data source object, the pooling vendor data source object performs a lookup in the connection cache to determine if the pooled connection object is available. If one is available, it is used. If the pool connection object is not available, the JDBC driver's vendor's connection pool data source creates a new pool connection object. In either case, a pool connection object is made available. The pooling vendor data source object then invokes the pool connection get connection method to obtain a connection object, which it returns to the application to use as normal connection. Because the JDBC driver vendor implements the pool connection interface, The JDBC driver creates the connection object. However, this connection object is not physical connection as in the non-pooling case. The connection object is a handle to the physical connection maintained by the pool connection object. When the application closes the connection by calling connection.close method, the connection event is generated and is passed to a cache module. The cache module returns the pool connection object to the cache to be reused. If the application does not have access to the pool connection .close method, only the connection pooling module as part of its cleanup activity issues the pool connection.close method to actually close the physical connection. Here the interface connection pool data source in package javax.sql in module java.sql. The factory for pool connection objects, an object that implements this interface will typically be registered with a naming service that is based on the Java naming and directory interface JNDI. Here the interface data source, a factory for connections to the physical data source that is that this data source object represents. An alternative to the driver manager facility, that a data source object is preferred means of getting a connection. An object that implements the data source interface will typically be registered with the naming service based on the Java naming and directory JNDI API. Interface pool connection in package javax.sql in module java.sql, an object that provides hooks for connection pool management. A pool connection object represents a physical connection to a data source. The connection can be recycled rather than being closed when an application is finished with it, thus reducing a number of connections that need to be made. Interface connection event listener, an object that registers to be notified of events generated by pool connection objects. Class connection event, an event object that provides information about the source of the connection event, connection related event. Connection event object are generated when an application closes a pool connection and when error occurs. Connection event object contains two kinds of information: the pool connection closed by the application. In the case of an error event, the SQL exception about to be thrown to the application. Interface pool connection, an object that represents hooks for connection pool management. A pool connection object represents a physical connection to a data source. The connection can be recycled rather than being closed when an application is finished with it, thus reducing the number of connections that need to be made. Interface connection in java.sql in package java.sql in module java.sql. The connection session with a specific database. SQL statement are executed and results are returned within the context of a connection. Here the JDBC driver vendor data source implements connection data pool data source. And here then connection data pool data source creates pool connection. Here the pooling vendor data source implements data source interface here. pooling vendor data source use connection pool data source, and here the pooling vendor data source maintain pooling vendor connection cache. Pooling vendor connection cache is connected to can have many pool vendor data source, and pool vendor data source has a one pooling and connection cache. And here pooling vendor data source is connected to a pool connection, and pooling vendor data source can have many pool connections, and one pool connection can have one pooling vendor connection cache. Here pooling vendor connection cache is connected to connection event listener. Here the pool connection is connected to connection event listener via plus event source and plus event listener, and here connection event listener is connected to connection event via use. Here the pool connection is connected to connection event via create, and here JDBC Driver vendor pool connection implements pool connection, and here the pool connection is connected to a connection via create. Here we are considering multi-data source configuration. Here the multi-data source configuring multi-data sources for use with here Oracle Rack RAC. To connect WebLogic server to multiple Oracle RAC nodes using multi-data sources, first configure a generic data source for each Oracle RAC instance in your Oracle RAC cluster with the Oracle Thing driver. Then configure multi-data source using either algorithm for load balancing or algorithm for failover, and add generic data source to it. This figure shows the typical multi-data source configuration. You can use WebLogic Server Administration Console or any other means that you prefer to configure your domain, such as WebLogic scripting tool, WLST or a JMX program. To use a database connection in this configuration, your application look up one multi-data source on JNDI tree and then request a connection. The multi-data source determines which generic data source to use to satisfy the connection request based on the algorithm type specified in the configuration. That is failover or load balancing. Here you can see a multi-data source are in WebLogic servers. Here data sources are in multi-data source here. Here also data sources are in multi-data source here. Data source is connected to here rack. This data source is connected to rack node 1 RAC1 RAC node 1. Here this data source is connected to RAC node 1 here, and these two data sources are connected to RAC node 2 here. Here RAC nodes interacts with shared storage. Here RAC nodes are node 1 and node 2 interconnect. Here you can see the database connection life cycle. Every database read or write operation requires a connection. So let's see how connection how database connection flow looks like. The flow goes like this. Step 1, the application data layer asks the data source for a database connection. Step 2, the data source will use the database driver to open a database connection. 3, the database connection is created and the TCP/IP the TCP socket is opened. For the application reads and writes to the database. 5, connection is no longer required, so it is closed. And 6, the connection is the 6, the socket is closed. You can easily reduce that opening and closing connections are quite opening or closing connections are quite an expensive operation. For example, PostgreSQL uses a separate OS process for every client connection, so high rate of opening or closing connections is going to put a strain on your database management system. Most obvious reasons for reusing a database connection would be reducing the application and database management system, OS IO overhead for creating or destroying a TCP connection, or other reason is reducing JVM object garbage. Here the interface data source in package javax.sql in module java.sql. The factory for connections to the physical data source, that this data source object represent an alternative to the driver manager facility. A data source object is the preferred means of getting a connection. An object that implements the data source interface will typically be registered with the naming service based on the Java naming and directory JNDI API. Interface driver are the interface that every driver class must implement. Interface connection, a connection session with a specific database. SQL statements are executed and results are returned within the context of a connection. Class socket factory in package javax.net in module java.base. This class creates sockets. It may be subclassed by other factories which create particular subclasses of sockets and thus provide a general framework for the addition of public socket level functionality. class socket in package java.net in module java.base. This class implements client sockets, also called sockets. A socket is an endpoint for communication between two machines. Here the application is connected to java.sql.data source via get connection, and data source is connected to driver via connect, and here the drive is connected to connection, and connection is connected to socket factory via create socket, and socket factory is connected to socket via new, and then socket is connected to the RDBMS. Then socket is connected to socket factory is connected to connection is connected to driver is connected to data source is connected to application, then application is connected to data source via close, application is connected to connection via close, and connection is connected to socket via close, then socket is connected to the RDBMS. Here you can see a pooling connection management flow. To understand why the pooling solution performs so well, we need to analyze the pooling connection management flow. Whenever a connection is required, the pooling data source will use the available connection pool to acquire a new connection. Pool will only create a new connection when there is no available ones left and the pool hasn't yet reached its maximum size. The pooling connection close method is going to return the connection to the pool instead of actually closing it. Here the interface data source in package javax.sql and in module javax.sql, a factory for connections to the physical data source that this data source object represent. Alternative to the driver managed facility that a data source object is preferred means of getting a connection. An object that implements the data source interface will typically be registered with a naming service based on Java naming and directory JNDI API. Here the interface connection, the connection session with the specific database. SQL statement are executed, the results are returned within the context of connection. Here the application is connected to data source via get connection, and data source is connected to the pool via acquire, then pool is connected to the connection, then connection is connected to the pool, pool is connected to the data source, and data source is connected to the application, then application is connected to the connection via close, and here the connection is connected to the pool via release. Here you can see pooling connection management flow in a different way. Whenever a connection is requested, pool data source will use the available connection pool to acquire a new connection. The pool will only create a new connection when there is no available ones left in and pool hasn't yet reached the maximum size. The pooling connections close method is going to return the connection to the pool instead of actually closing it. Here the get connection is connected to acquirable. If acquirable is yes, it's acquired is connected to acquired, and if it is no, then check for max size, and if the max size is yes, then weight, and then if weight is connected to the acquired, and if the max size is not, then increment pool size to the acquirable here, and here the if it is timeout, then retry. If the retry is no, then it's failure, and if yes, it's connected to the acquirable again, checking for acquirable. Here you can see life cycle of a data source object. Data source defined in Java.SQL package is an abstraction layer for Java database applications. Database applications may use JDBC context to find data source attributes that are configured on the deployment server. You can obtain data source objects in two ways, using JDBC without using JDBC. JDBC is an API accessing different kinds of naming and directory service. JDBC is not specific to a particular naming or directory service. It can be used to access many different kinds of systems, including file systems, common, object request broker architecture, COBA, Java remote method invocation, RMI, and enterprise Java beans, EGB, as well as directory services such as lightweight directory access protocol, LDAP, and a network information service, NIS. Although you can use JDBC to access a set of relational databases, you can use JDBC to access a set of naming and directory services. You will from a portability point of view, the obtaining data source interface using JDBC is more portable than not using JDBC. The data source interface provides an alternative to the driver manager class. Making a connection to a data source using data source implementation is better for two important reasons. It makes code more portable, and it makes code easier to maintain. A data source object represents a real-world data source. Depending on how it is implemented, the data source can be anything from a relational database to a spreadsheet or a file tabular format. When a data source object has been registered with the JDBC naming service, an application can retrieve it from naming service and use it to make a connection to the data source it represents. For example, JDK 1.4 documentation defines javax.sql.data source as follows: a factory for connection to the physical data source that this data source object represents, an alternative to the driver manager facility. A dataset object is a preferred means of getting a connection. An object that implements the data source interface will typically be registered with the naming service based on the JDBC API. Data source interface is implemented by a driver vendor. Three types of implementation exist. Basic implementation produces a standard connection object. Connection pooling implementation produces a connection object that will automatically participate in connection pooling. This implementation works with the middle tier connection pooling manager. Distributed transaction implementation produces a connection object that may be used for distributed transaction and almost always participates in connection pooling. This implementation works with the middle tier transaction manager and most always with the connection pooling manager. Data source object has properties that you can modify when necessary. It is, for example, if the data source moves a different server, you can change the property from the server. Benefits: the benefit is because the data source's properties can be changed. Any code accessing that data source does not need to be changed. A driver that is accessed via a data source object does not register itself with the driver manager facility. Rather, a data source object is retrieved through a lookup operation and then used to create a connection object. With the basic implementation, the connection obtained through a data source object is identical to the connection object obtained through a driver manager facility. This is according to structs. As a rule, you should always use a connection pool to access a database. The data source interface is preferred way to implement the connection pool today. Many containers and database systems now bundle a data source implementation that you can use. Most often, the data source is made available through JNDI. The JNDI approach makes it easy for you to your business classes to access data source without worrying about who set it up. When connecting to a data source, a relational database such as MySQL or Oracle, using a data source object registered with the JNDI naming service rather than using the driver manager facility, and you get three benefits. It makes code more portable, it makes code easier to maintain, and you get benefit of connection pooling. For example, in JDBC 2 introduced the data source interface that eliminates connection URLs and driver names in your Java applications. Data source enables you to register using JNDI naming instances of the data source with unique name. Then the other application can retrieve the registered data source using unique name. A data source object provides a new method for JDBC client to obtain a DBMS connection represented as java.sql.connection. Data source object is usually created, deployed, that is registered and located, lookup operation, and managed separately from Java application that use it. This figure shows the lifecycle of a data source object. In this figure, note that the directory and naming service item in JNDI enabled and can bind, register, and hold number of data source objects. Most databases can use COBA based naming and directory services, but in order not to tie yourself with a specific implementation of JNDI, in this chapter here you see to use the file system based reference implementation of JNDI SPI driver from Javasoft. In real production applications, you should select a commercially available naming and directory service product, such as, for example, older Sun's directory server or Novel's directory server, and so on. One Java application 1, can create data source using some data source configuration from an XML file, a relational database, or a file-based system. Also, Java application 1 can register or bind and manage the created data source in registering a data source. You have to associate the data source with the unique key. Once the data source is registered, it is accessible to other applications such as application 2. The application 2 can get registered. The application 2 can get registered data sources using lookup method by providing the unique key. Some vendors such as BEA's WebLogic and IBM's WebSphere provide tools to deploying data source objects and then provide browsing lookup operations to get data source objects. Here you can see application 1 is connected to create the data source via create, and here created data source is connected to directory and naming service, and deployed data sources via deploy here, and it is connected to create data source via manage. Here the Java application 2 is connected to directory and naming service and deployed data source via lookup, and here the directory and naming service and deployed data sources are connected to the application 2 via data source. As an example, we can consider interface data source, a factory for connections to the physical data source that This data source object represents an alternative to the driver manager facility. The data source object is the preferred means of getting a connection. An object that implements the data source interface will typically be registered with a naming service based on the Java naming and directory JNDI API. This is in the module java.sql and in the package java.sql. The data source interface is implemented by the driver vendor. There are three types of implementation. One, basic implementation produces a standard connection object. Two, connection pooling implementation produces a connection object that will automatically participate in connection pooling. This implementation works with a middle tier connection pooling manager. 3, distributed transaction implementation produces a connection object that may be used for distributed transactions and almost always participate in connection pooling. This implementation works with the middle tier transaction manager and almost always with the connection pooling manager. As an example, we can consider this code segment. After a basic data source implementation is deployed by the system administrator, it is ready for programmers to use. This means that a programmer can give a logical data source name that was bound to an instance of a data source class. The JNDI naming service will return an instance of that data source class. The method getConnection can then be called on that data source object to get the connection of that data source object to get the connection to the data source it represents. For example, a programmer might write this type of code here. First line of this code here, this line, gets an initial context as the starting point for retrieving a data source object. When you supply the logical name here JDBC fast coffee DB at deployment time, on the when you supply the logical name JDBC /fast coffee DB to the method lookup, the method returns the data source object. That the system administrator bound to the JDBC /fast coffee DB at deployment time. Because the return value of the method lookup is a Java object, we must cast it to the more specific data source type before assigning it to variable ds. The variable ds is a connection, is an instance of the class that implements the data source interface. Calling the method ds.getConnection produces the connection to the database. GetConnection method requires only the username and the password because the variable ds has the rest of the information necessary establishing the connection with the database here. And here the connection pool data source object are deployed. A programmer can use a data source object to get the pool connection here. the code for getting the pool connection is just like the code for getting non-pool connection. You can see here the variable ds represents a data source object that produces the pool connection to the database coffee break. You need to retrieve the data source object only once, because you can use it to produce as many pool connections as needed. Calling method get connection on ds variable automatically produces the pool connection, because the data source object that ds variable represent was configured to produce the pool connections. Connection pooling is generally transparent to the programmer. There are only two things you need to do when you are using pool connections. Use data source object rather than the driver manager to get a connection. In this code, ds is a data source object implemented and deployed so that it will create pool connections, and username and passwords are variables that represent the credentials of the user and user that has access to the database. And use finally statement to close pool connection. This finally block would appear after try catch block that applies the code in which pool connection was used. Yeah. Otherwise, an application using pool connection is identical to the application using regular connections. Only other thing an application programmer might notice when connection pooling is being done is that performance is better. Here you can see now we are considering some data source limits in database metadata. Some of the methods in this category are here. Another group of methods provides the limits imposed by a given data source. Some of the methods in this category are get max row size, get max statement length, get max table in select, get max connections, get max char literal length, get max columns in table. Methods in this group return the limit as an int. A return value of 0 means that there is no limit or limit is unknown. Now we are considering as an example, we are considering now data source properties in the data source interface in connections. Here setting and getting a data source property. Here the property property name server name, type string, and description database server name. The JDBC API defines a set of properties to identify and describe data source implementation. The actual set required for specific implementation depends on the type of the data source object. That is whether it's a basic data source object, a connection pool data source object, or an XA data source object. The only property required for all data source implementation is description. Data source properties follow the convention specified for properties of Java Beans components in Java Beans 1.01 specification. Data source implementations may augment this set with implementation specific properties. If the new properties are added, they must be given names that do not conflict with the standard property names. Data source implementations must provide getter and setter methods for each property they support. These properties typically are initialized when the data source object is deployed, as in code example here, in which when the data source object implements data source interface. Here you can see getting and setting a data source property. Data source properties are not intended to be directly accessible by JDBC clients. This design is reinforced by defining the access methods on the implementation class rather than on the public data source interface used by applications. Furthermore, the object that the client manipulates can be a wrapper that only implements data source interface. The setter and getter inner methods for the properties need not be exposed to the client. Management tools that need to manipulate the properties of data source implementation can access those properties using introspection. Here you can see, now we are considering the JNDI API and application portability. Here registering a data source object with the JNDI based naming service. The Java and directory interface JNDI API provides a uniform way for application to access remote services over the network. This here we describe how it is used to register and access a JDBC data source object. See the JNDI specification for complete description of this interface. Using the JNDI API, application can access a data source object by specifying its logical name. A naming service using the JNDI API maps its logical name to a corresponding data source. This scheme greatly enhances portability because any of the data source properties such as port number or server name can be changed without impacting JDBC client code. In fact, the application can be redirected to a different underlying data source in a completely transparent fashion. This is particularly useful in the 3-tier environment where an application server hides the details of accessing different data sources. Here you can see this example illustrates the use of JNDI based naming service to deploy a new vendor data source object. Here the registering data source object with the JDBC based naming service. Note the Java EE components use a special convention for naming their data sources. Here the create a vendor data source object and set some properties. Use the JDBC API to register the new vendor data source object. Reference the root JDBC naming context, and then bind the logical name JDBC/ACMEDB to a new vendor to the new vendor data source object. Now we are considering getting a connection with the data source object. Getting a connection object using data source object. Here the method connection get connection in interface data source in package java x.sql in module java.sql attempts to establish a connection with the data source that this data source object represents. Once the data source object has been registered with the JDBC naming service, an application can use it to obtain the connection to the physical data source that it represents, as is done in this code example. Here getting connection object using data source object. The data source implementation bound to the name JDBC/ACMEDB can be modified or replaced without affecting the application code. Here they get the initial JDBC naming context. Get data source object associated with the logical name JDBC/ACMEDB and use it to obtain the database connection. Now we are considering connection dot close in closing connection objects. An application calls the method connection.close to indicate that it has finished using a connection. An application calls the method connection.close to indicate that it has finished using a connection. All statement objects created from a given connection object will be closed when the close method for connection object is called. Once the connection has been closed, any attempt to access any of its methods with the exception of close, is closed, or is valid methods will result in a SQL exception being thrown. Now we are considering connection pool data source and pool connection. Here we are considering the connection pool data source interface in connection pooling. The interface connection pool data source in package javax.sql in module java.sql, a factory for pool connection object. An object that implements this interface will typically be registered with the naming service that is based on the Java naming and directory interface JNDI. Typically, JDBC implements the connection pool data source interface, and the application server uses it to obtain pool connection objects. The code example here shows the signatures for two versions of the get pool connection methods. Here the connection pool data source interface here. The pool connection objects represent the physical connection to a data source. The JDBC drivers implementation of pool connection encapsulate all its details of maintaining that connection. An application server caches and reuses pool connection object within its implementation of the data source interface. When a client calls the method data source.getConnection, the application server uses the physical pool connection object to obtain logical connection object. This code example shows the pool connection interface definition. This is pool connection interface. When application is finished using the connection, it closes the logical connection using the method connection.close. This closes the logical connection but does not close the physical connection. Instead, the physical connection is returned to the pool so that it can be reused. Connection pooling is completely transparent to the client. The client obtains a pool connection using pool connection and uses it just the same way it obtained and uses a non-pool connection. When the connection.close is called when using connection pooling, any properties that were set by connection.set client info will be cleared. Now we are considering connection events. A connection event listener interface defined the following two methods which correspond to the two kinds of events that can occur on a pool connection object. The connection event listener, the interface connection event listener in package javax.sql in module java.sql, an object that registers to be notified of event generated by the pool connection object. Here the connection event listener interface defined the following two methods which correspond to the two kinds of events that can occur on a pool connection object. Connection closed, triggered when the logical connection object associated with this pool connection object is closed, that is the application called the method connection.close. Connection error occurred, triggered when a fatal error such as a server crashing causes the connection to be lost. Recall what recall that when an application calls the method connection.close, the underlying physical connection, the pool connection object, becomes available for reuse. Java Bean style events are used to notify the connection pool manager, the application server, that is pool connection object that can be recycled. In order to notify of an event pool connection object, the connection pool manager must implement connection event listener interface and then registered as a listener by pool connection object. The connection event listener interface defined these two methods which correspond to the two kinds of event that can occur in a pool connection. A connection pool manager registers itself as a listener for pool connection object using the pool connection.addConnection event listener method. Typically, a connection pool manager registers itself connection event listener before returning a connection object to an application. The driver invokes the connection event listener methods connection close and connection error occurred when corresponding event occur. Both methods take connection event object as a parameter, which can be used to determine which pool connection object was closed or had an error. When the JDBC application closes its logical connection, the JDBC driver notifies the connection pool manager, the listener, by calling the listener's implementation of the method connection closed. At this point, the connection pool manager can return the pool connection object to the pool for reuse. When an error occurs, the JDBC driver notifies the listener by calling its connection error occurred method and then throws an SQL exception object to the application to notify it of an same error. In the event of the fatal error, the bad pool connection object is not returned to the pool. Instead, the connection pool manager calls the pool connection.close method on the pool connection object to close the physical connection. Now we are considering connection pooling in a three-tier environment. The following sequence of steps outline what happens when a JDBC client requests a connection from a data source object that implements the connection pooling. The client calls the data source.getConnection. Then the application server providing the data source implementation looks in its connection pool to see if there is a suitable pool connection object. The physical database connection available. Determining the suitability of a given pool connection object may include matching the client's user authentication information or application type, as well as using other implementation specific criteria. The lookup method and other methods associated with managing the connection pool are specific to the application server. Then if there are no suitable pool connection objects available, the application server calls the connection pool data source dot get pool connection method to get a new physical connection. The JDBC driver implementing connection pool data source create a new pool connection object and return it to the application server. Then regardless of whether the pool connection was retrieved from the pool or was newly created, the application server does the same internal bookkeeping to indicate that the physical connection is now in use. Then the application server calls the method pool connection dot get connection to get the logical connection object. This logical connection object is actually a handle to physical connection object, and it is this handle that is returned by the data source dot get connection method when connection pooling is in effect. The application server registers itself as a connection event listener by calling the method pool connection dot add connection event listener. This is done so that the application server will be notified when the pool connection object is available for reuse. Logical connection object is returned to the JDBC client, which uses the same connection API as the basic data source case. Note that the underlying pool connection object cannot be reused until the client calls the method connection.close. The connection pooling can also be implemented in two-tier environment where there is no application server. In this case, the JDBC Driver provides the both implementation, the data source which is visible to the client, and underlying connection pool data source implementation. Now we are considering data source implementation and connection pooling. In basic data source implementation, the following are true. The data source.get connection method creates a new connection object that represents the physical connection and encapsulate all of the work to set up and manage that connection. The connection.close method shut down the physical connection and frees the associated resources. Aside from improved performance and scalability, the JDBC application should not see any difference between accessing a data source object that implements the connection pooling and one that does not. However, there are some important differences in the application server and the driver level implementation. A basic data source implementation, that is one that does not implement connection pooling, is typically provided by the JDBC Driver vendor. In a basic now we are considering deployment. Here the deploying a connection pool data source. Deploying a connection pool data source object. The connection pool data source interface connection pool data source in package javax.sql in module java.sql factory for pool connection object. An object that implements the interface will typically be registered with the naming service that is based on the Java naming and directory interface JNDI. The deploying a data source object that implements connection pooling requires that the both client visible data source object and underlying connection pool data source object be registered with JNDI naming service. First step is to deploy a connection pool data source implementation as it is done in this code example. This is a deploying a connection pool data source object. Once this step is complete, the connection pool data source implementation is available as a foundation for client visible data source implementation. The data source implementation is deployed such that references to the connection pool data source implements as shown in here. Here the deploying data source object backed by a connection pool data source object. The data source object is now available for use in an application. Here the connection pool DS implements the connection pool data source interface, create an instance and set properties. Register the connection pool DS with JNDI using the logical name JDBC/pool/bookserver_pool. Here the pool data source implements the data source interface, create an instance and set properties. Reference the previously registered connection pool data source. Register the data source implementation with JNDI using the logical name JDBC/bookserver. Now we are considering reuse of statement by pool connections. The interface pool connection in package javax.sql in module java.sql, an object that provides hooks for connection pool management. A pool connection object represents a physical connection to a data source. The connection can be recycled rather than being closed when an application is finished with it, thus reducing the number of connections that need to be made. The JDBC specification provides support for the statement pooling. This feature, which allows an application to reuse the prepared statement object in much same way it can reuse the connection, is made available through a pool connection. As with the pool connection object itself, the prepared statement object can be reused in multiple logical connections in a transparent manner. Now we are considering statement events. The statement event listener interface defines the following two methods, which correspond to the kinds of events that can occur on a prepared statement object. The statement clause, triggered when the logical prepared statement object associated with this pool connection object is closed, that is an application called the method prepare statement.close. Statement error occurred, triggered when the JDBC driver determines that the prepared statement object is no longer valid. If the connection pool manager supports statement pooling for the prepared statement object, it must implement the statement event listener interface and then registered as a listener by the pool connection object. The statement event listener interface defines the following two methods, which correspond to the two kinds of event that can occur on a prepared statement object. Connection pool manager registers itself as a listener for prepared statement object using pool connection.addStatement event listener method. Typically, a connection pool manager registers itself as a statement event listener before returning a prepared statement object to an application. The driver invokes the statement event listener methods and statement clause and statement error occurred when corresponding event occur. Both methods take statement object as a parameter, which can be used to determine the prepared statement object was closed or had an error. When the JDBC application closes its logical prepared statement, the JDBC driver notifies the connection pool manager, the listener, by calling listener's implementation of the method statement close. At this point, the connection pool manager can return the prepared statement object to the pool for reuse. When an error occurs that makes the prepared statement object invalid, the JDBC driver notifies the listener by calling statement error occurred method and then throws the SQL exception object to the application to notify the same error. Now we are considering connection pool data source properties. Setting connection pool configuration properties. Here the property name max statements, type int. Description, the total number of statements that the pool should keep open. 0 indicates that caching of statement is disabled. As with the data source interface, the JDBC API defines a set of properties that can be used to configure the behavior of connection pools. The property initial pool size int, the number of physical connection the pool should contain when it is created. Min pool size int, the number of physical connection the pool should keep available all times. 0 indicates that connection should be created as needed. Max pool size int, the maximum number of physical connections that the pool should contain. 0 indicates no maximum size. Middle time int, the number of seconds that the physical connection should remain unused in the pool before the connection is closed. 0 indicates no limit. Property cycle int, the interval in seconds that the pool should wait before enforcing the current policy defined by the values of the above connection pool properties. Connection pool configuration properties follow the convention specified for Java Beans components in the Bean specification. Connection pool vendors may choose to augment this set with the implementation specific properties. If so, the additional properties must be given the names that do not conflict with the standard property names. Like data source implementation, the connection pool data source implementations must provide getter and setter methods for each property they support. These properties are typically initialized when the connection pool data source object is deployed. The code example here illustrates setting properties in a vendor implementation of the connection pool data source interface. Here setting connection pool configuration properties. The properties on the connection pool data source object apply to the pool connection objects that it creates. An application server managing the pool of the pool connection objects uses these properties to determine how to manage its pool. Connection pool data source configuration properties are not intended to be directly accessible by JDBC clients. Management tools that need to manipulate the properties of the connection pool data source implementation can access those properties using introspection. Now we are considering XA data source and XA connection. Deploying a data source object backed by an XA data source object. The module, the interface XA data source in package javax.sql in module java.sql. The factory for XA connection object that is used internally. An object that implements the XA data source interface is typically registered with a naming service that uses the Java naming and directory service interface JNDI. Deploying an XA data source object is done in exactly the same manner as the connection pool data source objects. The two-step process includes deploying a XA data source, XA data source object and the application visible data source object as it is done in this code example. This is a deploying a data source object backed by XA data source object. Here the com.acme.jdbc.xa data source implements the xa data source interface. Create an instance and get and set properties. First register XADS with the JNDI naming service using the logical name JDBC/XA/inventory_XA. Next, register the overlying data source object for application access. com.acme.appserver.datasource is an implementation of data source interface. Create an instance and set properties. Reference the previous registered XA data source. Register the data source implementation with the JNDI naming service using the logical name JDBC/inventory. Exception example, we can consider SQL exception. If a database access error occurs in the method connection get connection in interface data source. As an error example, we can consider this error occurred in the environment with GZD and JDBC. The data source configuration failed WAX72091 connected to the process server 1 on node, etc. Now we are focusing on JDBC Driver. A JDBC driver is a software component enabling a Java application to interact with a database. JDBC drivers are analogous to ODBC drivers, ADO.NET data providers and OLEDB providers. Here you can see JDBC driver types. Type 1 JDBC driver. Type 1 JDBC drivers translate JDBC calls into ODBC calls. Type 1 JDBC drivers are usually called JDBC ODBC bridge drivers. Type 2 JDBC driver. Type 2 JDBC drivers translate JDBC calls into native DBMS APIs. Type 2 drivers consist of Java component and native code component, which requires that binary code be loaded on each client machine. Type 3 JDBC drivers are pure Java drivers. that uses database middleware. Type 3 drivers communicate with the database through middleware servers that must be running in the network. The NET protocol allows the client JDBC drivers to be very small and load quickly. Fetching data rows may take longer because the data comes through middleware server. Type 4 JDBC driver. Type 4 JDBC drivers are pure Java drivers that accesses a database directly. The Type 4 drivers are sometimes called the thin drivers. Type 4 JDBC drivers have a relatively fast performance. Here you can see type 1, 2 and 3 and 4 drivers. In type 1 you can see in client here Java client or JDBC or DBC bridge and JDBC drivers are there. Java client is connected to JDBC ODBC bridge, and JDBC ODBC bridge is connected to ODBC driver, and ODBC driver interacts with data source. In type 2 you can see Java client, JDBC native library and native library are inside client tier. Java client is connected to JDBC native library. JDBC native library is connected to native library, and native library interacts with data source. Here Java client is inside the client tier. Java client is connected to middle tier. App1 applications and application server and three tier JDBC driver are in middle tier. Middle tier is connected to data source. In type 4 Java client and all Java JDBC driver are inside client tier, and Java client is connected to all Java JDBC driver, and all Java JDBC driver interacts with data source. Here you can see JDBC drivers and databases. Here Java application interacts with JDBC interface. JDBC interface is connected to driver Oracle, driver ODBC, driver Sybase here, and driver Oracle is connected to Oracle database. Driver ODBC is connected to Microsoft Access. Driver Sybase is connected to Sybase database. As an example, we can consider this database connection URL in MySQL, where localhost is the name of the server hosting your database and 3306 is the port number. Here you can see the syntax here. In here host : port is the host name and port number of the computer hosting your database. If not specified, the default values of host and port are 127.0.01 and 3306 respectively. Database is the name of the database to connect to. If not specified, the connection is made with no default database. Failover is the name of the standby database. MySQL connector /J supports failover. Property name equal property value represent an optional ampersand separated list of properties. These attributes enable you to instruct MySQL connector /J to perform various tasks. As an example 2, we can consider this database connection URL in Java DB. You can see the syntax here. Here in sub protocol is specified where the Java DB should search for the database either in a directory, in memory, in a class path, or in a jar file. It is typically omitted. Database name is the name of the database to connect to. Attribute equal value represent an optional semicolon separated list of attributes. These attributes enable you to instruct Java DB to perform various tasks, including following. Point 1, create database specified in the connection URL. Point 2, encrypt the database specified in the connection URL. Specify directories to store logging and trace information. Specify a username and a password to connect to the database. As the example 3, we can consider this driver for this is for PostgreSQL. Before JDBC version 4 and Java SC 1.6, there was no generic mechanism in the JVM that would enable services to be discovered and registered automatically. Because of that, the manual step was needed to load the JDBC driver class by name. Here, the method public static class dot for name string class name throws a class not found description here. If there's an error, and this method returns the class object associated with the class or interface with the given string name. Here a call for name causes the class name here this one to be initialized. As the example 4, we can consider this driver oracle.jdbc.driver.oracle driver. Here this class for Oracle database. As the example 5, we can consider the driver class for the Sybase database, sybase.jdbc.sqlanywhere.idriver. As the example 6, we can consider this one. Here is an example of using tpipe to write the results of an SQL query on a table in MySQL database. The MySQL connector J is the official JDBC driver for MySQL. Once you have extracted the distribution archive, you can install the driver by placing MySQL connector Java version bin.jar in your class path, either by adding the full path to your class path environment variable or by directly specifying it with the command line switch cp when starting the JVM. Now we are considering types of drivers in connections. There are many possible these implementations are categorized as follows. The type 1 drivers that implement the JDBC API as a mapping to another data access API such as ODBC. Drivers of these types are generally dependent on the native library, which limits their portability. The JDBC ODBC bridge driver is an example of type 1 driver. Type 2 drivers that are written partly in the Java application language and partly in native code. These drivers use a native client library specific to the client source to which they connect. Again, because of the native code, their portability is limited. Type 3, the drivers that use a pure Java client and communicate with middleware server using database dependent protocol. The middleware server then communicates the client's request to the data source. Type 4, drivers that are pure Java, often using a network protocol or file IO to communicate with the specific data source. The client connects directly to the data source. There are many possible implementations in JDBC drivers. These are the categories. Now we are considering a driver interface. Example, static initializer for a driver implementing here. Driver implementing a java.sql driver. Here the when a driver implementation is loaded here, the interface driver in package java.sql in module java.sql, the interface that every driver class must implement. JDBC drivers must implement the driver interface, and implementation must contain a static initialization that will be called when the driver is loaded. This initialization registers a new instance of itself with the driver manager as shown in this example. When driver implementation is loaded, the static initialization will automatically register an instance of the driver. To ensure that the drivers can be loaded using this mechanism, drivers are required to provide a no argument constructor. The driver manager class invokes driver methods when it wishes to interact with the registered driver. The driver interface also includes the method accepts URL. The driver manager can use this method to determine which of its registers driver it should use for a given URL. When a driver manager is trying to establish a connection, it calls the drivers connect method. And passes the driver URL. If the driver implementation understands the URL, it will return the connection object or throw a SQL exception if the connection cannot be made to the database. If the driver implementation does not understand the URL, it will return null. Loading a driver that implements java.sql.driver. As part of its initialization, the driver manager class will attempt to load available JDBC drivers by using the JDBC.driver system property, which contains a fully qualified list of class names of JDBC drivers. Each driver is loaded using the system class loader. Service provider, so of the java.sql.driver class. For service providers, class that are loaded via the service provider loading mechanism. JDBC 4.0 drivers must provide a support for service providers of the java.sql.driver class. This is loading a driver using JDBC.drivers system property. Note the driver manager initialization is done lazily and looks up service providers using the thread context class loader. Drivers loaded and available on application will depend on the thread context class loader of the thread that trigger the driver initialization by driver manager. When a driver manager.get connection is called, the driver manager will attempt to locate the suitable driver from amongst those loaded in the initialization and those loaded explicitly using the same class loader as the current application. Existing application currently load JDBC drivers using class.forename method will continue to work without modification. Now we are considering driver action interface. So here the example static initialization for driver implementing java.sql.driver and java.sql.driver action. Interface driver action in package java.sql in module java.sql, and interface that must be implemented when a driver wants to be notified by the driver manager. JDBC driver may implement a driver action interface when the driver wants to be notified by the driver manager method deregister driver. The driver action implementation is not intended to be used directly by applications. A JDBC driver may choose to create a driver action implementation in a private class to avoid it being called directly. The JDBC driver's static initialization block must call driver manager.register driver java.sql.driver and then java.sql.driver action in order to inform driver manager which driver action implementation to call when the JDBC driver is deregistered. Here the example is static initialization for driver implementing java.sql.driver and java.sql.driver action. Now we are considering packaging JDBC drivers in connector RAR format, RAR file format in relationship to connectors. This is an example of a resource adapter deployment descriptor. Resource adapters can be packaged along with the deployment descriptor into a resource adapter archive or RAR file. The RAR file contains the Java class or interfaces, native libraries, deployment descriptor, and other resources need to be deployed to the adapter. The deployment descriptor maps the classes in the resource adapter to the specific roles that they perform. The descriptor also details the capabilities of the resource adapter in terms of what level of transactional support it provides. The kind of security it supports, and so on. The code example here is an example of a deployment descriptor for JDBC Driver. The class com.acme JDBC manager connection factory could be supported by an implementation of a java x.sql.x data source. The resource adapter section contains the information on the level of a transaction support. The mechanism used for authentication, and configuration information for deploying the data source in the JDI space. JDI namespace. Example, we can consider class not found exception in if the class cannot be located in the method for name string class name in class As an error example, we can consider this error occurred in the environment with MySQL on Tomcat 7.0 server. The error is com.mysql.jdbc.driver occurred as a result of class not found exception. Now we are focusing on database. Database, also called electronic database, any collection of data or information that is specially organized for a rapid search and retrieved by a computer. Databases are structured to facilitate the storage, retrieval, modification, and deletion of data in conjunction with various data processing operations. A database management system, DBMS, extract information from database in response to queries. Here you can see architecture of the Oracle JDBC drivers and Oracle database. The in addition to supporting the standard JDBC application programming interfaces, APIs, Oracle drivers have extensions to support Oracle specific data types and to enhance performance. JDBC thin driver. The JDBC thin driver is a pure Java type 4 driver that can be used in applications and applets. It is a platform independent and does not require any additional Oracle software on the client side. The JDBC thin driver communicates with the server using SQL*net to access the Oracle database. The JDBC thin driver allows a direct connection to the database by providing an implementation of SQL*net on top of Java sockets. The driver supports the TCP/IP protocol and requires a TNS listener on the TCP/IP sockets on the database server. JDBC OCI driver. The JDBC OCI driver is a type 2 driver used with Java applications. It requires an Oracle client installation and therefore is Oracle platform specific. It supports all installed Oracle net adapters including IPC, named pipe, TCP/IP, and Internet Work Packet Exchange, Sequence Packet Exchange, IPX, SPX. JDBC OCI driver, written in combination of Java and C, converts JDBC invocations to call OCI using native methods called to C entry points. These calls communicate with database using SQL*net. The JDBC OCI driver uses OCI libraries, C entry points, Oracle.NET, call libraries, and other necessary files on the client computer where it is installed. OCI is an API that enables you to create applications that use the native procedures or functions calls to the third generation language to access Oracle database and control all phases of SQL statement processing. JDBC server-side thin driver. JDBC server-side thin driver offers the same functionality as the JDBC thin driver that runs on the client side. However, the JDBC server-side thin driver runs inside the Oracle database and accesses a remote database or a different session on the same database. This driver is useful in following scenarios: accessing a remote database server from Oracle database instance acting as a middle tier, accessing an Oracle database session from inside another, such as from a Java stored procedure. The use of JDBC thin driver from the client application or from inside the server does not affect the code. JDBC server-side internal driver. The JDBC server-side internal driver supports any Java code that runs inside the Oracle database, such as in Java stored procedures, so enterprise Java bean EJB, and must access the same database. It lets the Java virtual machine JVM to communicate directly with the SQL engine. The driver supports only JDK 1.4.1. The JDBC server-side internal driver, the Oracle JVM, the Oracle database, and SQL engine all run within the same address space, and therefore the issue of network round trips is irrelevant. The programs access the SQL engine by using function calls. The JDBC server-side internal drive is fully consistent with the client-side drivers and supports the same features and extensions. Here you can see JDBC thin driver and is connected with the and Java sockets. Java sockets interacts with SQL engine, PL SQL engine. Here you can see JDBC OCI driver, OCI C library interacts with SQL engine and PL SQL engine. PL SQL engine and Java Engine and KPRBC library are inside Oracle database. SQL Engine and PLSQL Engine interacts with Java Engine, and RBC library. Server-side thin driver and JDBC server-side internal driver are inside Java Engine, and Java Engine interacts with JDBC server-side internal driver interacts with KPRBC library, and Java Engine that server-side thin driver interacts with Oracle database in another Oracle database. As an example, we can consider connecting to MySQL database. You can see the database connection URL here, and syntax is here. Here host and port is the host colon port is the host name and the port number of the computer hosting your database. It is not specified. The default values of host and port are 127.0.0.01 and 3306 respectively. Database is the name of the database to connect to. If not specified, the connection is made with no default database. Failover is the name of the standby database. MySQL connector J supports failover. Property name equal property value represent an optional ampersand separated list of properties. These attributes enable you to instruct MySQL connector J to perform various tasks. As an example 2, we can consider this one. This is to connect to PostgreSQL database. There are different URL forms here. You can see those are here. Here the host, the host name of the server default to localhost. So to specify an IP version 6 address, you must enclose the host parameter with square brackets for and here the port number the server is listening on default to the PostgreSQL standard port number 5432, and database. The database name default is to connect to a database with the same name as the username. And in addition to the standard connection parameters, the driver supports a number of additional properties which can be used to specify additional driver behavior specific to PostgreSQL. These properties may be specified in either connection URL or additional properties objects. Parameters to driver manager.getConnection. Here user, the database user on whose behalf the connection is being made here. Password, the database user's password. SSL, the connect using SSL. The server must have been compiled with SSL support. This property does not need a value associated with it. The mere presence of it specifies a SSL connection. However, for the compatibility with future versions, the value is true, is preferred. As the example 3, we can consider this URL to connect with to a Oracle database. You can see the syntax here. The first part of the URL specifies which JDBC driver is to be used. The supported driver type values for client-side applications are thin and OCI. The brackets indicate that the username and password pair are optional. The database specifier value identifies the database to which application is connected. Here you can see the host name, port number and SID. We can consider this one, this URL to connect to Sybase database. You can see JDBC Sybase TDS. This is the host name and port, and in the syntax there can be / database here, and connection underscore property values. As an example 5, we can consider this one with Quarkus JDBC data source at the agrowal extension plus one of JDBC DB2, JDBC Derby, JDBC H2, JDBC MariaDB, JDBC MS SQL, JDBC MySQL, JDBC Oracle, or JDBC PostgreSQL. Then configure your data source. As here, here the database kind define which type of database you will connect to. Here PostgreSQL. Here database credentials. Here configuring your JDBC connection the JDBC URL, and here the connection pool size. Now we are considering creating a database metadata object. Here the creating and using database metadata object. The interface database metadata in package java.sql in module java.sql. Comprehensive information about the database has a whole. A database metadata object is created with the connection method get metadata. Once created, it can be used to dynamically discover information about underlying data source. The code example here creates a database metadata object and uses it to determine maximum number of characters allowed for a table name. Here the con is a connection object. Now we are considering retrieving general information. Some database metadata methods are used to dynamically discover general information about data source as well as some details about its implementation. Some of the methods in this category are get URL, get username, get database provider product version, get driver major version and get driver minor version, get schema term, get catalog term, and get procedure term. Nulls are shorted high and nulls are shorted low. Uses local files per table, get SQL keywords. Now we are considering determining feature support. A large group of database metadata methods can be used to determine whether a given feature or set of features is supported by the driver or underlying data source. Beyond this, some of the methods describe what level of support is provided. Some of the methods that describe support for individual features are supports alter table with drop column, supports batch update, supports table correction names, support position delete, support full outer joins, supports stored procedures, supports max case quoted identifiers. Methods to describe the level of feature supports include support ANSI 92 entry level SQL, supports core SQL grammar. Data source limits. Another group of methods provides the limit support imposed by a given data source. Some of the methods in this category are get max row size, get max statements length, get max tables in select, get max connections, get max char literal length, get max column in table. Methods in this group returns a limit as an int. Return value of 0 means that there is no limit or the limit is unknown. SQL objects and their attributes. Some of the database metadata methods provide information about the SQL object that populate a given data source. This group also includes methods to determine attributes of these objects. Methods in this group return result set object in which each row describe a particular object. For example, the method get UDI UDTs returns the result set object that which there is a row for each UDT that has been defined in the data source. The examples of this category are here the get schemas, get catalogs, get tables, get primary keys, get procedures, get procedure columns, get UDTs, get functions, and get function column. The result sets objects that are returned from the database metadata method have a sensitivity of type underscore forward underscore only and concurrency of conquer underscore read underscore only. The result set dot get holidayability can be called to determine the holidayability of the returned result set object as a default holdability. The result set dot get holdability can be called to determine the holdability of the returned result set object as a default holdability is implementation defined. Additional column beyond the column defined to be returned by result set object is for a given method can be defined by JDBC Driver vendor must be accessed by their column label. This allows for future JDBC specification to be able to add additional columns if needed to existing database metadata methods without a significant impact to existing applications. Now we are considering transaction support. A small group of methods provide information about the transaction semantics supported by the data source. Example of this category include supports multiple transactions, get default transaction isolation. Now we are considering new methods. The JDBC 4.3 API introduces the following new database metadata methods. Support sharding method used to indicate whether the JDBC driver and database support sharding. The complete definition of these methods may be found in the JDBC API specification Java doc. Now we are considering modified methods. JDBC 4.3 modifies the data definition of these existing database metadata methods. Get tables clarify that the remarks column may return null. The JDBC 4.3 is the JDBC 4.3 API specification include updated definition of these methods. As an exception example, we can consider PSQL exception. The class PSQL exception is in package org.postgresql.util. As an error example, we can consider this error: this connection has been closed at org.postgresql.jdbc2.abstract jdbc2 connection. Check close at etc. This is end of the my presentation. Thank you very much for watching it.